development. Author is Adam Sinke. About the author, Adam Sinke. Career highlights include releasing the highest grossing Android app multi-screen and multitasking and working with Cold Fusion on Works Launcher. So, author studied about multitasking in 2000s era. That means when multitasking and Android was starting, and smartphones markets were evaluating, or they were expanding. So in that era, author studied about multitasking and working with Cold Fusion on Vox Launcher. Now multi-screen and multitasking came as pre-installed software and over 60,000 headsets from Indian OEMs, that is original equipment manufacturers like Intex and Cellcon. So this multitasking was a huge thing back then. So in that era, our author, studied multitasking, and he started few, that means short apps like calendar and browser. They were on the same screen, like split screen. So he did that. uh, Introduction. Unity makes process of game development quick and easy and enjoyable. So Unity makes game development enjoyable. Hopefully you will be surprised at just how easy it is to get something that looks quite professional up and running, and to share that with a huge audience of millions of users for fun or for profit. So Unity makes all this process very enjoyable, or what we can say easy, and it makes practically possible to develop game. Otherwise it is not possible for a individual. That said, I know that getting started with any kind of development can be daunting, especially if you are completely new to coding. So any kind of development, that means uh, Java development, or software development, or web development, it can be daunting. That means it can be difficult, especially if you are completely new to coding. That means if you don't know about any of type of coding like C++, etc. So it can be difficult, but Unity is helping us. Now that is why this book walks you through every step in simple and easy manner, from setting up development environment. So this book helps you a lot in setting up your development environment and installing all necessary software, right down to releasing completed APK to Google Play Store. So you will learn the basics of programming with C hash, as well as to design a game that people will actually enjoy playing. So with help of this book, we will learn basics of a language like C hash, and we will be able to develop a game that will people actually play. Chapter 1. Why this is an incredibly exciting time to develop games for Android. This is a golden age for independent game developers. There was a time like this once before. It was during early days of home computer, the days of the ZX Spectrum and Amstrad. So here the author is saying that this is an important age, or a golden age. That means opportunity. That means it is an opportunistic age. That means we have a lot of opportunities for game development for an individual game developer. No matter how big your development or your budget, there was only so much you could do with your hardware. That means during the early age of home computer, no matter how big your development or your budget, there was only so much you could do with your hardware. This put everyone on a new level of playing field, and meant that a keen programmer could have a veritable hit like Acnoid from the comfort of their basement. So during that age it was uh, uh, easy to build games. Not only does every model in game like that need to be designed from scratch and every single line of dialogue need to be recorded, but simply coding the amount of physics that determine the way things explode would be impossible undertaking for lone developer. But it was still difficult for a lone developer to perform physics on different objects in game. The fate interval, the growth in mobile devices and operating systems like iOS and Android introduced a new lower spec devices. So Android and iOS operating systems are now evolved, and they are introducing a new lower spec devices like for a few dollars or few thousand $100 we can get a proper working or a decent working Android device, or which is capable of gaming also. So it has introduced a new lower spec devices. Meanwhile, better distribution channels like Google Play Store, iTunes App Store, and even Steam have helped smart time developers get their creations discovered. So there are also a lot of platforms like Google Play Store, iTunes App Store, and even Steam. They are helping for building games and launching games. Slowly, more and more indie developers began releasing games to critical acclaim, and over time, this eventually translated to commercial success. So, a lot of individual developers began releasing their games on Apple App Store and Google Play Store, and this eventually translated to commercial success means this was translated means this was converted into commercial success, that means they are earning. So they were earning a lot. Later artistic attempts like Limbo or Photonica have shown that stylistic visuals can be just as eye-catching as hyper-real graphics. So Limbo was a game, and Photonica, these games have shown that not only graphics, that means higher hyper-real graphics or very real graphics they should be used, but also stylized visuals can also be eye-catching. So these games have shown that. With many gamers gradually becoming indifferent towards generic, big budget sequels like Overegged, Call of Duty franchise, indie games have crafted a niche for themselves and gained a reputation for being able to offer experiences that are more creative and daring. Notable for examples are popular walking sims have been gained popularity lately. That means it has shown that individual developers can also produce games, and they can be profitable too, like high end games also. So individual developers have also proven that they can also make money. Entering unity or enter unity, although many factors have contributed to rapid growth of indie games. So that means many factors have contributed for rapid growth of individual developments like Google Play Store, App Store, etc. It is also true that tools like Unity have contributed greatly to this movement. So tools like Unity, they are also helping for this movement of individual game developers. A game engine is a software backbone that provides a lot of basic elements needed to make a game work. So game engine basically is a software that provides basic tools embedded in it for an individual game developer for making game work. These elements include things like ability to display, that is render 3D and 2D graphics, handle basic physics called a physics engine, and detect collisions between game objects. or collision engine, and even provide a basic AI scripts or other ready-made assets. So these are assets which are included in a game engine. So game engine includes ability first of all to render, that is display 3D and 2D graphics. So it displays 3D and 2D graphics. Then it handles basic physics called as physics engine. So physics include, for example, object is falling due to gravity. So that includes physics. Now detect collisions between game objects. So collision between game object, that means if we are um colliding with an enemy, so our character will be shaken. So that is collision between game objects or collision engine. So collision engine is used for that, and even provide basic AI scripts or other ready-made assets. Instead of creating a game from scratch, a tool like Unity allows a team of developers to focus on elements that make their game unique and then simply insert them into working environment. So a tool like Unity is helping or allowing team of developer to focus on elements that are making game look different than other, that is unique, and then simply insert them into working environment. That means working environment is uh, the environment of game. Now Unity combines this with a handy interface and cross platform functionality. Platform functionality, that means it can be used for Android as well as iOS devices, and thereby saves countless thousands of hours that would otherwise be necessary to build a fully realized game. That means it is saving a countless coding time or countless hours that would otherwise be necessary to build a fully realized game from scratch and part and port it to Android, iOS, and Windows. So one game can be played on a single game can be played on Windows also, Android also, and iOS also. That is cross platform functionality. So cross platform functionality is basically being able to use one software in various systems or ecosystems. If Unity is providing the underlying code for your physics, then did you really make the game? And if it's providing a user friendly graphical interface for dragging and dropping pre made game assets, how it is any different from Game Maker? Is that far removed from Super Mario Maker? So that means, uh, is it so that means if it is so easy to make a game with the user friendly graphics and uh, every helpful tool, so are we really making a game? And are we different from that Super Mario Maker? Means, are we different from other game developers? Then make no mistake, Unity is a comprehensive tool that is used by thousands of developers, big and small. Many of your favorite games on Android and elsewhere are most likely built using Unity, including famous games. So this is list of games that were built using Unity. First is Temple Run, second is Bad Piggies, third is Lara Croft Go, fourth is Deus Ex The Fall, fifth is Escape Plan, sixth is Battlestar Galactica Online, seventh is Rust, eighth is Super Hot, ninth is Lucky's Tale, 10 is Mountain Man Valley, 11th Cuphead, 12th Ori and Blind Forest, 13 Bro Force, and 14 is Tilth Brush. So all these games were built up using Unity. So if we are using Unity, we are not different than other developers. So because almost all developers are using Unity and game engines. Using ready-made assets is far from a sign of being less professional. In fact, it is one of the most important and encouraged strategies in coding. So, using ready-made assets is not any less than being a being a coding professional. So, it is not being less than a professional. In fact, it is one of the most important and encouraged strategies in coding. So, it is it is one of the encouraged strategy in coding. One of the key mantras any good programmer follows is don't reinvent the wheel. So this is very important mantra, or we can say formula or saying that don't reinvent the wheel means don't reinvent the things that are already invented. In other words, don't spend large amount of time working like something working on something like physics engine, AI, or even 3D models when that work is already exist and is available to use. So this work is already available to use, like engine physics and AI and 3D models. So these are already available. So don't work on them again. Doing so simply isn't a good use of time. With games becoming increasingly more complex and ambitious, sharing assets and codes. That means doing so is a good use of time. That means it saves time, but also it is becoming increasing. So game development is becoming more complex. So so this is a good use of time to use the previously available assets and codes. So it is not only wise, it is necessary for professional developers. So it is necessary also for professional developers. No, this is amateurs should follow suit. So amateur should follow this suit means amateur should use such game engines. When Unity is such a proven quantity, when you know that it's a capable of producing massive hit title, why would you make life more difficult for yourself by ignoring it? That means if it is being used for producing a massive hit titles, that means very famous games. So why you are uh, making your life difficult? That means why you are increasing your difficulties by not using it Unity or ignoring Unity. So it makes no sense to ignore Unity. We should use Unity. Now, sharing assets. The ethos of sharing is an important part of modern development, and it only takes a Google search to realize this. Unity removes need for much of the complex coding that you otherwise here to handle yourself. And if you want to make a very basic 2D platformer, then you will hardly have to write any code at all. So if we Google search about how to make a game, so we will come to know that it is very difficult to make a game. It takes complex coding for making a game. So Unity is avoiding all that. When you do have to write code, you will normally find someone willing to help you out if you ask the question in forum or elsewhere. So when you ask some question about coding, so you will find someone to answer your question. So there is a forum of code in which you will write code, or you can ask for help. So there is a large pool of developers. From time to time, you will need code that isn't available in Unity itself and that you don't want to have to create from scratch. For example, a particular visual effect or an advanced control scheme. Unity actually built a solution right into software itself. There is no need to travel the web or download files and import them into your project. The Unity Asset Store is a resource where you can download scripts, models, sprites, textures, special effects, and much of all provided by the community or Unity Technologies itself. So, Unity actually built a solution. So, the Unity Asset Store is a resource where you can download all the scripts, models, sprites, etc. So, we don't have to search web or do a lot of hard work. So, lot of stuff is available in their Unity Asset Store. Better yet, many of the assets are free. Others incur a relatively small price. By taking full advantage of this feature, you can create pretty much anything you can imagine while writing barely a line of code. So many of the assets are free and some are very cheap. That means they incur a relatively small price. This open source spirit of sharing and another thing that has helped indie developers take off in such a big way recently. That means this spirit of sharing, that means sharing resources that we have, it is another thing that helped indie developers take off in such a big way recently by crowdsourcing and borrowing elements for their games. So they borrow elements from their games. Developers can build a huge worlds with a professional level of polish. So with sharing those resources, a developer can build huge worlds with professional level of polish in fraction of time that would otherwise be necessary. You can download it, get started right away, and polish to Steam or Google Play Store with no limitations until your game starts ranking in over 100k dollars a year. So you can download those free resources, use them, then create your own games, and you can publish. With there are some conditions actually for publishing to Google Play Store and Steam, that you have to pay $40 for starting an account. So you can publish it to Steam and Google Play Store with no limitations until your game starts ranking in over 100k dollar a year. When game is starting earning 100k dollar, so at that point we will need to pay for license, and it is reasonable. You also need to pay if you have an investment of over 200k per year. So that means we have investment of over 200k per year. That means if we are having a big budget game, so uh, we have to pay also. Some features are also accessible for paid accounts too, but most first-time developers don't need to worry about that at this point. You should be excited. By using Unity, you get to build a game with precisely the same tools used by some recent developers. So a lot you can use the those same tools which are used by professional developers using Unity. Building something basic requires hardly any coding, and when you do need unique elements, you can normally obtain them online. The learning curve here is incredibly generous considering the quality of game you will be able to develop, and it is completely free. So there is a lot of free data or free teaching available. So you can develop games for completely free. If you have been dreaming of being a game developer but thought it was out of reach, think again. It has never been easier. And with Unity and this book at hand, nothing can stop you. So, if you are thinking that being a game developer is not easy for you, then think again. With help of Unity and this book, we can create a lot of games and make money also. Why mobile devices are perfect for indie projects. The other great thing about Unity is that it's a cross platform. You can make games on your Windows PC and then sell it on Android, iOS, Xbox, PlayStation, and more. So it supports a cross platform functionality. That means one software can be used in various operating systems, and more some of these require that you will have to apply for a developer license. So that means we will have to apply for a developer license, then we can use it. Purchase a developer kit or face other restrictions. Purchase a developer kit or face other restrictions. That means we can start our accounts on these platforms. Now in theory, though cross platform possibilities are endless. So in theory, that means technically we can apply for various cross platform like iOS, Xbox, etc. So possibilities are endless in technically. And you will see later in this book, Unity even supports virtual reality platforms like Samsung Gear VR, Oculus Rift, HTC Vive, and Google Daydream. So these are also VR platform also. So this Unity supports VR platform too. But the focus of this book is going to be Android. That is because Android is most open source and biggest of all platforms. So we are focusing on Android because Android is the biggest platform and it is open source also. It also has a lowest barrier to entry. So that means it is easier to start our Android account. And you will find it is generally the easiest platform to be successful with. Take a look back at the list of big games made with Unity again, and you will notice that a lot of them are mobile games. So take a look at big games made with Unity again. That means the list of games. So that most of them were Android games. One reason for this is that the both Unity and mobile platform attract indie developers. There are two reasons why mobile is ideal for indies. So why we are using or focusing more on Android? So there is a reason for this. Mobile gives you access to huge audience via simple distribution channel. So uh, it is giving a huge audience because Android devices are available to more people. So it gives a audience via simple distribution channel. Then mobile lowers the expectations for your game and therefore the amount of work involved in its creation. That means it lowers expectation for your games. That means, put simply, if you build a game for Xbox One, it's going to compete with likes of Call of Duty and Grand Theft Auto. Although there is a thriving indie scene on Xbox, the potential graphical fidelity is still much higher and even input is more complex. So that means if you are making or creating games for PC, so you have to complete with legendary GTA series or Call of Duty series. So it is not possible for an individual developer to generate such high graphic or highly complex games. So mobile games is comparatively easier. That is why endless runners are more popular on mobile but not on other. Endless runner games include Temple Run. So these are a lot of popular on mobile devices, and they are less popular on PC. So that is the reason behind it. That means if you are a mobile game creator, then you will face a less competition as compared to PC game developer. On mobile device, this is acceptable because it provides an ideal 2-minute distraction while you are in line at bank. But most people would not want to sit down to play an endless runner for an length of time, hence they are relatively rare on consoles and PCs. That means mobile games are meant to be played for 2-minute distraction. That means for less time, for playing for less time. So people don't sit on console for like 5 minutes. They sit on console for 1 hour, 2 hours. So mobile games are meant to be played for um, a short distraction. This doesn't mean you can produce rubbish, of course. It simply means that mobile gamers are much more lenient and prefer bite sized entertainment. Obviously, this bite sized nature is often going to be reflected in price, but that just means you can potentially sell at higher volume. That means that means it is not necessary that you will produce any low quality game and it will work out in uh, mobile game industry. In that industry it has a competition also among those games, but it is less competitive as compared to console games or PC games. Several entries in the Grand Theft Auto series have been successfully ported to mobile, as have twin stick shooters, RPG, and others. So, mobile gaming also has a competition because several PC console games are also been shifted to mobile games. So, it has a competition. Most people these days have some kind of smartphone, probably running iOS or Android, and this includes a wide range of different demographics. That means a lot of people are having smartphones like Android and iOS. Why Android is better than iOS for developers? So mobile is a great, but Android specifically is even better. Why? Well, for starters, Android apps can now also appear on range of devices other than smartphones. So that means Android is better because a lot of people have Android phones as compared to iOS. Android is completely open source OS. That means open source. That means OEMs, original equipment manufacturers, can modify it to run on televisions, smart watches, e-readers, washing machines, and wide range of other hardware. So it is an open source OS, and it has become very popular. Practical advantages of Android over iOS. There are practical advantages of choosing Android over iOS as well. A couple of hours. You can come up with an idea of app, put something together, and have it live within 24 hours. So practically you can uh, make something and have it live within 24 hours. That means you can release it on that day. To make any real money with game on Android, you will want to try and get into the Google Play Store, where users can reach for apps and download them. Doing so cost a single one of fee of rupees of $25, and all handled automatically. So you can start our account for very less amount of money. The app uploads and goes through an automated approval process, and within a few hours, people will be able to start downloading it. You can do this as many times as you like without needing to pay again. Your app will only get taken down if it violates Google policies. That means it is like when you upload an app, then it will be running automatically. So you will not have to pay for monthly or anything. Once it is uploaded, it will be uploaded and it will be downloaded by people. This is a real breeze compared with Apple's process, which first of all requires an annual recurring fee of $99. Even if you only have one app to get a couple of downloads per month, you will be paying $99 each year to keep it live. So in Apple's App Store, it is more expensive as compared to Android. Now I know at least one developer who had a joke app rejected because it was not funny or entertaining enough. So they have a lot of moderators also, so they can reject your applications also. The risk with iOS though is that you spend months creating an app you are very happy with only for it to be rejected and never see light of the day. So with the iOS developer, there is a risk that you are working hard for a particular app, and then that app gets rejected. So there is a risk also. What's more, using Android simply gives you more creative freedom and more content when it comes to control. So being an Android developer is uh, more secure. On another thing, in order to develop for iOS, you are going to need to buy yourself a Mac computer, an iOS device to test on. This in contrast to developing for Android, which you could theoretically do without even needing an Android phone by using emulators. So you will need a Mac computer for testing or developing devices. But in case of Android, uh, you will also don't need an Android phone also, you can use emulators. Android versus iOS for dollar. The first good news, there are considerably more users on Android compared with iOS, but iOS users are likely to spend 2.5 times more on apps than Android users are. Put simply, iOS users tend to have a little more money in their pockets and are somewhat more inclined to use it. In reality, that 2.5x is equivalent to 1.08 versus 0.43 per app iOS. So Android is better. That means there are more users on Android. There is simply too much investment and risk involved in developing for iOS, and barriers to entry are too high. Android, on the other hand, allows you to start developing games right away and reach a much larger audience with more creative freedom and less chance of your creation being rejected. Android and Unity, a match made in heaven. That means Android and Unity are compatible with each other. Hopefully, you are now convinced that Android is a platform of choice for indie game developers. So, Android is a platform of choice. That means for indie developers, Android is helpful. The other key part of our strategy is Unity 3D. We have already seen some of the incredible advantages that Unity offer, and by choosing to develop for Android with Unity, you artistically lower the barriers or becomes entry for becoming developer. So it is easier for Android users for developing games. Now Unity interface incredibly is incredibly beginner friendly and allows you to simply drag and drop many of elements around screen as needed. That means Unity interface is easy and lot of tools are available there. As we have seen, Unity is also cross-platform and allows you to publish multiple formats at touch of a button. That means Unity can also be used for Android devices, iOS devices, etc. It is a cross-platform and it can publish multiple platforms at a touch of a button. How to choose your first project? Using Unity 3D, the possibilities are pretty much endless. You can create anything from a simple puzzle game to a fully realized 3D first person shooter. Thanks, thanks to Moore's law, the capabilities of average smartphone are now such that near console quality titles are able to fit in your pockets. That means using Unity 3D, we can make high-end games like console quality games. And thanks to Moore's law means that semiconductor technologies are evolving and thus processing capabilities of smartphones are ever increasing. So console quality games are fitting in our pockets now. But that does not mean you should set out to make the next Call of Duty. It is entirely possible to develop a highly detailed 3D game for Unity, but that doesn't mean You should. So that means you should not at first, in your first attempt you should not go for Call of Duty, because these games are complex. So because they involve a lot of 3D stuff. This is where the vast majority of first time developers go wrong. So this is where first time developers are going wrong, and it is one of the first and most important take home messages you need to learn from this book. So this is an important message that at your first attempt you should not go for complex stuff. Simply put, most first time developers have aspirations that far outstrip their capabilities. They simply overlook the need to regain in their ambitions for their first projects. So they want their first project to be massive or huge, and that is where they go wrong. You will need cutscenes, voiceovers, music, sprawling play areas, multiple levels for one person in this project. So if you go too complex in your first project, so you will need cutscenes, then voiceovers, music, sprawling play areas, multiple levels, etc. So which is difficult for your first game. That could take years and years, by which point technology would have moved on and everything you created would probably end up looking outdated. That's essentially what happened to Duke's Nukem Forever, and that was a game with a large experienced studio behind it. So Duke Nukem Forever was a game which became outdated. This is one reason why the most successful indie games tend not to sport the most lifelike graphics. They instead choose original art styles that are eye catching while simultaneously reducing workload for creators. The best strategy for creating a successful indie title. Look at something like Limbo, a game available for Xbox, PlayStation, Windows, and mobile. This was an early indie hit and sold incredibly well and made big splash in gaming community. So Limbo was a very popular game. This was possible partly this was possible partly thanks to art style which entirely used silhouettes that suited the tone and the image of the game while also looking stunning and visually interesting. So thanks to art style which entirely use silhouettes. That means thanks to art style that means art style of that game was very good, and as the indie game it did well. Better yet, by choosing to work with silhouettes, Playdead drastically reduced the amount of detail needed for sprites and game and in-game elements. So uh, it reduced so use of Unity reduced uh, amount of detail needed for sprites. Now, of course, not every game can use silhouettes, but you are going to need to think outside the box. One option that is particularly popular is to use pixel art. This is a retro looking style that emulates graphics from uh, old old 8 and 16-bit consoles. So pixel art is a emulator which which emulates graphics from old 8 and 16-bit consoles and has very nostalgic appeal. So pixel art is also useful. Considering gameplay, the same approach should be taken to gameplay, especially for your project. Instead of aiming to make first person shooter that requires you to create 3D models and large maps filled with details, it makes much more sense to attempt something 2D, ideally with procedural generation or other techniques. So it is not always essential to first that your first project should be 3D game. So initially you will go with a 2D game because it is easier. So it will reduce your workload. Procedural generation Procedural generation means that game elements are added at random according to an algorithm, removing the necessity to create levels manually. So procedural generation is a technique in which we can create same elements again and again, like trees, bushes, etc. So that is procedural generation. Replayability comes from trying to reach top scores and from the fact that no two runs will be ever be identical. So replayability, that means people play games again and again, which is coming from uh, that urge to acquire top scores. And then there is comes the fact that no two runs will be ever identical. That means each time game will be different. So this is another reason that people play games again and again. Games like Rayman Fista, Rayman Fista Run, Cannabalt, and Mario's Run have sold in huge numbers using this very simple formula. So Mario Run, Cannabalt, and Rayman Fista have sold more a lot because of this simple formula that uh, people want to play it again and again. That is replayability. Flappy Bird can also be seen as a variation on traditional infinite runner formula. So Flappy Bird was also successful. Other games use even simpler gameplay mechanics. The fantastic Super Hexagon by Terry Kavanagh utilizes very inventive graphics compared of hexagons moving inward towards center of screen, which creates a trippy effect. So, Super Hexagon is a game by Terry Kank, and it has a special effect which creates a trippy effect. And a simple objective of processing on left and right sides of screen. Try to move your avatar into small gaps in each layer. So this is the rules for playing that game, that is Super Hexagon. So here's what we are going to do. Put the world changing RPG on hold for a while and instead consider taking on something smaller for your first project. So that means world changing RPG, that is that huge complex level project apart right now, and think about something smaller for your first project. So first project will be smaller. Forget Pragan Slayer 3D and think more in terms of retro catching game. So first think about some retro catching games. The good news is that Unity has a 2D mode that makes the strategy a lot simpler and alters the UI and features to support 2D game development. So Unity has a inbuilt dedicated 2D mode which supports 2D game development. In business, this approach is known as fail fast. Instead of creating a product that takes years of research and development and thousands of dollars of investment, you simply move on your next idea. But if it gains traction in the marketplace, then you spend some time developing idea and taking it further. There is nothing more soul destroying than pouring years of your life into a game only for it to get 10 downloads and one star review. So create a MVP, minimum viable product, get into Play Store and then develop it only if it finds an audience. So that means first you should go for smaller project and then you should invest your time in bigger projects. What you will learn in this book: the project you will be working on will be basic enough that you can easily adapt it to fit your own purpose, and by changing a couple of sprites and giving it fresh title, you will be ready to release your game within weeks. Chapter 2: Introducing Unity and Getting Set Up. So in this chapter we will be discussing about what is Unity and how to set up, that is downloading require files, etc. Now Unity is an incredibly powerful tool that makes it considerably quicker and easier to create some awesome games. So Unity is a powerful tool that makes it easier to create some games. Unity as a game engine, where you to program a game entirely from a scratch without using a pre-existing game engine. You would need a code every single detail yourself, which would mean huge amount of development before you even got to start adding things like levels. That means without using a game engine, it would be very difficult for us to code every single piece. Now there is simply no benefit to coding the way a wooden crate should fall and break that's already been handled for you. The complexity of today's games would make it impossible for one person to go it alone, were it not for existence of solutions like Unity. So the complexity of game development is so high that without Unity it becomes impossible for an individual. Unity is also cross compatible, meaning it can act like bridge between your code and whatever device you are targeting. So that means like Android, iOS, etc. So it is cross compatible. Now Unity as IDE. So IDE means integrated development environment. So we know that there are various integrated development environment for programming of microcontrollers, then for C, uh, using C language, etc. We have different IDEs. So Unity as IDE. So Unity is also an IDE, that is integrated development environment. What makes Unity such a blessing for developers, though, is that it is once a game engine and a game market with user-friendly interface that allows elements to be easily dragged and dropped around the screen. So it is a user-friendly game engine, and it is allowing elements to be easily dragged and dropped around screen. Many people also like the flow of Unity, which allows you to build games using simple system of entities like game objects. This is certainly a matter of opinion, but suffice to say that Unity is for the most part very intuitive and easy to use as a beginner. Unreal, on other hand, has a steeper learning curve and it is not well organized. So, on other hand, Unreal Engine is difficult, but Unreal 4 has better graphical capabilities for developing AAA looking games. So Unreal 4 has better graphical capabilities. It is also open source, which effectively means that you can access source code and make changes to engine itself. Neither of these things is going to be an issue for indie developers targeting mobile devices. So Unity wins. That means in mobile devices we don't need high graphics, so Unity is better than Unreal. Now licenses, as if Unity weren't already awesome enough, the best part of all this is that it is completely free to use. So Unity is completely free to use, so this is a plus point for Unity. The free account that you will want to start with personal account, this account costs nothing and Unity doesn't even take royalties. So free account can be started without any royalties. Keep in mind that this 100k dollar restriction also applies to money raised, meaning money raised. So this 100k restriction is applying to money raised, meaning that if you raise money on Kickstarter and exceeds 100k dollar limit, then that counts. So if you are earning 100k dollars per month or yearly, so we will have to pay. So there is limit also. Downloading Unity and required components. The Android SDK is the software development kit. So SDK stands for Software Development Kit. This is a set of software tools provided by Google that can act like a bridge in accessing the functionality of your hardware. So this software set of software tools acts like a bridge in your hardware uh, while accessing your hardware, that is Android phone or a smartphone. In other words, it provides source code that Unity needs to make your game compatible on Android platform. So it is providing a source code. So this is what your computer needs to support Java development, and because Java is main language for of Android, you will need it to go ahead. So Java is important language in Android and you will need it to go ahead. We will be downloading this first. Visual Studio is what you will use to handle the actual programming in Unity. So Visual Studio is used along with Unity. When you start writing scripts, you will edit this separate Visual Studio window. Edit these scripts in separate Visual Studio window, but we can worry about it later. So that means we when we write scripts, we will edit in Visual Studio window. Creating your battle station, that is work setup. It is also worth thinking about your actual setup and work environment, because this can make a big difference to your enjoyment during development and can solve your headaches later on. So creating your battle station, that means uh, setting up your work equipments. So that is about creating your battle station. So it can make a big difference to your work and save you headaches later on, that means save your issues later on. One big advantage, for example, is to have a large monitor and possibly even ultra wide 21 by 9 display. So a large monitor is important if possible. Now Unity has lot of different windows and panels, as we will see in chapter 3, and it is big advantage to be able to see all this at same time. So that means Unity software has different windows and panels, so you can juggle tasks more easily. A big screen will provide a big boost to your multitasking. So big screen, that means multiple screens will provide a big boost to your multitasking, then help you avoid your eye strain and improve immersion, that is removing distraction, and it helps you to view properly, that means it will avoid eye strain. Now if you prefer to work on laptop, make sure it's one with a large screen, that is 18.3 inches or larger. So large screen is important also in laptop and has enough horsepower to cope. If you plan on doing a lot of development, investing in a good space for work is good way to spend your money and will result in better end product completed more quickly. Starting your first project. Installation finished, great. At this point, you should have Unity and all necessary components you need for it installed on your computer and ready to go. And hopefully you are eager to jump in and get started. So that means uh, for starting first project, it is assumed that you have did setup of everything. In that case, let us launch Unity for the first time and do just one last bit of setup. So launch Unity. Now first you will head to need to sign in to account to you created on website. If you have not done that already, click the link and you will be taken. So first you have to sign in for starting project to relevant page where you can set one up. You can then log in using your new Unity ID, and you will need to confirm that your company is making less than the threshold if you want to stick with the free account. So there is free account option also available and paid account also available. You also need to make sure that you choose 2D, so the game will automatically support 2D platform. So there are two options, that is 2D platformer and 3D platformer. So you can initially go for 2D because it is less complex. Setting paths. Let us do one last bit of setup by telling Unity where the Android SDK is located on our system. Head to top menu and find edit preferences external tools. You will then find a space to input the location of Android SDK, that is main folder, and Java JDK file. If your folder is located in app data, it may be hidden, so tell File Explorer to show hidden items under View tab and then track it down manually. It is there somewhere, just keep looking. So we have to edit preferences. That means we have to link JDK and SDK to Unity. Chapter 3, Finding Your Way Around Unity. What's all this then? Getting acquainted with IDE. When you get your first look at Unity, it can all appear rather confusing with lot of different windows, menus and options. So when you first look at Unity, so it can appear confusing with windows, menus, etc. Now scene. Right in center of Unity is a view called scene. This is where a lot of your work is going to get done, and is essentially the window where you will move your various game objects and arrange everything. You can zoom in and out, and if you were in 3D mode, you would also be able to move the camera around 360 degrees. So scene is basically it contains image and 3D characters. Asset store. At top of the scene window are two tabs that allow you to change between two different functions. So at top we have asset store, from which we can get different assets. Hit the asset store tab. As you might expect, the scene view will be changed for asset store view. The asset store is where you browse for various asset scripts, game objects, sprites, effects and more to include in your own application. In short, the asset store makes your life considerably easier. It store contains all these ready-made resources, which are mostly for free and some are for very less amount of money. That means some are paid but they are cheap, and mostly are free. That said, this is not something you are going to be needing for a while, so for now keep the tab on scene and don't worry about it. Game. There may be a third tab on this window as shown in the preceding figure called game. This view is where you will see actual game as it will be located, unless you choose to maximize the game as you play it. So there is a third tab called game. You have freedom to change the position of the window, and sometimes after an update, default setup can be moved around. You can drag and drop element into game view as you can in the scene view, and you can't select them to move them around either. For one, the perspective will be fixed to an in-game camera, meaning you will see what players will see when they launch game. Likewise, when there are multiple items sharing the x and y coordinates, the items on top will be one closest to camera along the z axis rather than one selected. So we can move objects in x and y axis. Services, usually located to right of the scene view, is the service tab, which shares a window with the inspector. For now you can completely ignore this window. These services will mainly come into effect for more ambitious projects and only once those apps are live in the Play Store. Next tab is Inspector tab. Next comes the tab that often shares its window with services, the inspector. So when you select a game object like sprite in the scene view, you will then be able to use the inspector in order to view things like name of the object, the dimension any script that might be attached and so on. So in inspector tab is used for that. Project, normally located along the bottom of the screen, is a window for project and console tabs. So on bottom of screen we have window for project and console tabs, and sometimes game will be here too. The project tab should be open by default and is where you can see all the individual files associated with your project. So in project tab we can see all individual files which are associated with a project. Right now your project only has one folder called assets, and in that folder is nothing. So when you don't do anything, we have only one folder called assets. This will be useful window as you work, because it will allow you to find sprites that you have created with other software and rename or delete files that you need in your game. So this project window is frequently used. We can add objects in project window also. Console, next to project tab is the console tab. This is where you can get information regarding the status of Unity and your app. So in console tab we are getting information about Unity and app. This will come in handy, but we won't need to worry about it for a little while. So keep project visible in front of it for now. So console tab is used for getting information regarding the status of our project or our app, that is it working or not. This will come in handy, but we won't need to worry about it. Hierarchy, finally, one of the most important elements in UI is the hierarchy, which is almost always found on the left of the screen. So hierarchy is found on left on screen. This lets you quickly find specific game objects to make edits, and it's the only way to select invisible objects like checkpoints. So in hierarchy we can find various game objects also. The hierarchy can also be very handy when you want to select multiple objects. So when we select multiple objects, hierarchy is very handy. Maybe all your collectibles for example, and has useful search utility for quickly retrieving specific items. Housekeeping, I recommend that you leave the window in their default configuration. In most cases they have been arranged like that for a reason. So housekeeping is one of the window, but you don't have to deal with it. Just keep it in a default configuration. So keeping housekeeping in default configuration works, and it will make it easier for you to follow along with instructions in this book. But if you find the UI feels cramped, or just don't like the way it is arranged at any point, you can hover the mouse pointer over any of the dividing lines to change the relative sizes. So you can change relative sizes of every sections. Now getting your toes wet with objects and scenes. That is enough theory. Time to get practical. To really understand how these windows work and what you need to get started, the best thing to do is to start building something. Now adding sprites. To get started then, let's begin by adding first game object, that is going to be simple 2D square. So we are adding a 2D square. Unlike working with 3D objects, there are no simple shapes for you to insert in 2D. That means any 2D object you introduce must be created first as sprites. Creating a square is simple enough, though we can literally start a new MS Paint file. So we can add an MS Paint files or our photographs also to make them as a game character. Now resize it to 50 by 50 pixels. For adding to game, we are resizing that to 50 by 50 pixels, and then just fill the space with a single block color. So we are making here a square character, which is a suppose a blue color or red color. So we are making a game character here, which is a square. Now save that as a png file and drag it from wherever you saved it to your project folder. So we are saving that as a png file, and then we are putting it into our project folder and call it square for simplicity, and we are saving it as a simplicity. Now to help us get into good habits early on, we will first create a folder in our project specifically for sprites. So we will create a folder in our project called sprites. We will call it sprite. Now and in the spirit of good habits and good nomenclature, we will call the folder sprites. To do this, right click your assets folder in project window and then go to create folder and name this folder as sprites. So we are creating a sprites folder. As we go, we will be creating more folders for our scripts, sounds and more. It is smart to create lots of folders to help us everything separate, so we can quickly retrieve the type of file we need at any given time. So we can retrieve any type of file we need at any time. Once you have made that folder, you can simply drag the square.png file from Windows Explorer into your sprites folder. Note that at any time you will also be able to right click your project window and select show in Explorer. So we can copy paste this file from Explorer to our project window. This will show you the assets directory within your project, and anything you put in here will show up in the project window once you refresh the view. So you can put your projects in assets directory. With that, the sprite is now a part of your project, and you can use exact same process whether you want to add sprites or trees, collectible enemies or anything else into your levels. It really is that simple. So this is same process for adding different collectibles, items and different objects in your game. Two ways to introduce game objects. There are two ways to add this simple game object into the scene, and we are going to go through both of them here because I feel it is a good learning opportunity. So there are two ways for putting game objects in the scene. The most straightforward way is simply to click the sprite in your project window and then drag it straight into your scene and drop it. So this is first way. That means simply click the sprite in your project window and then drag and drop it in project window. Now click the game view and you will see the square against a different shade of blue in background. The other way to add sprites to your scene is to head over the top menu and click and then game object 2D object sprite. When you do this, a new sprite will appear in your hierarchy window, but you won't be able to see it in the scene view because it is currently doesn't have an image file associated with it. So this is another way to add a game object. With new sprite created in hierarchy, open up the inspector window and notice the section called sprite rendered. In here, the first line says sprite known sprite. You can simply drag and drop your square file into here, or you can click small circular button next to box. While you are in the inspector, why not also take this opportunity to change the name of your second sprite, currently new sprite, to do something more interesting like square 2. Try both these methods and you will have two different sprites on screen in your scene window, square 1 and square 2. So square 2 is a different object than square 1. Now manipulating game objects. As you might have guessed already, you can very easily move your new sprites around scene view. So you can move those game objects around scene view simply by clicking them and dragging them around the screen. Under transform, the x and y values of positions change as you move the square, as I have done. That means you can just as easily change the positions by entering numbers in inspector. That means you can change positions by entering number. This will come in handy if you need to line things up perfectly or set them in a very specific position. That is something you will do a lot of. We will see later on, though, that there are also more effective ways to ensure that everything stays nicely lined up and snapped to a grid while we work. What about Z? I hear you ask. Well, the Z axis is largely redundant when creating 2D games, though not entirely. We will see later on that you can use this option to create parallax scrolling effect, and that it can also be useful for defining which sprite should be rendered for the player to see when there are multiple located in the same place. This can also be controlled by changing the Z order, which we will also look later on. Rotation and scale. You may have noticed that you also have two more interesting options under transform here in inspector. These are rotation and scale. They pretty much do what they say and allow you to alter the rotation and size of your sprites. We will ignore the rotation for now because we won't be needing that for a while, but you find that if you change the scale x and y from 1 to 2, your sprite doubles in size. Manipulating game objects in the scene view. If you wanted to do this freehand, you could opt to alternatively use the tools along the top of screen on left just above hierarchy window. These tools include a hand and the various arrows doing different things. So these are tools that we use in the scene view. So these tools have specific meaning, and they have specific functions also. These tools change the way you interact with scene view. You simply click the tool you want to interact, you want to intend, and then select it. The hand at the furthest left lets you drag the scene around and move your view, which is useful for scrolling through large level. So hand is used for moving your view for scrolling through large level. The tool that looks like four arrows on compass is what you use to move specific game object around screen. You can simply click the game object and start moving it around freely in scene view, or you can select it and then drag either red or green arrow to move it solely in x and y axis respectively. So that four arrow tool is used for moving game object. The two curved arrows indicate the rotation tool. Select this and a circle will appear around this selected game object that will allow you to rotate it in two dimensions. So these curved arrows are used for rotating the game object in two dimensions. Now then you have a scale tool. So scale tool is used, that is fourth tool, last tool, that is used for which gives us two arrows that you can use to scale object along each axis. So it is used for scaling object around each axis. So we are discussing about tools for manipulating game objects. So the final tool is your jack of all traders. It lets you drag the game objects, resize them by pulling on the corner or draw squares to select multiple objects on the go. Whether you move your objects around freehand with the tools or by changing numbers in the inspector, you can arrange your sprites however you like and conceivably create some nice looking landscapes. That means this tool is for drawing square and select multiple objects. Testing the game and using the camera. If there is one control in the UI that is likely to have caught your eye, it is play button. So play button is basically used for playing our app or playing our game or to execute. The good news is that this does exactly what you would hope. It allows you to test the game. So this is allowing us to test the game. Hit the play button and your game will run in game window, showing you two squares located on a light blue background. So after hitting this button, your game will run in game window. On a light blue background. It is probably not going to take world by storm, but congratulations, you just ran your first working program. This is our hello world, and things only get more fun from here. So we will first run our hello world program. While the game is playing, you can view it in the game view, and you can continue to make edits via inspector. So while game is playing, we can view it in game view, and we can make edits also. Just keep in mind that when you do this, nothing will save. If you move the sprite while game is running, it will then jump back to position where it last was. So you cannot edit while it is performing. Now as soon as you stop it again, use this for previewing changes live, but not for making permanent alterations to your code. Try to drum this into your head right now. To stop the game at any time, just hit the play button again. Note that if you want the game to be full screen, when you hit play, you can click maximize on play. The camera. The observant among readers may have noticed that there are more than just two game objects in the hierarchy view. The third object is called main camera, and if you select it, you will see that the white camera icon that is floating in your scene view. So game camera is basically focused on that a game character that is moving. So that is the camera. Main camera is a game object like your sprites, but with a camera component rather than sprite. When you add one of these to your scene, it defines where the player's perspective is and what are we going to see on screen. That means as the character moves, the camera will also move on screen. It may feel odd that your camera is treated in the exact same way as sprite, but this is what you need to understand about Unity. Everything is a game object. So in Unity, camera is also a game object. Scripts do not run unless they are attached to game objects, and this may require you to rethink the way you approach your code. If you are used to other languages, but once you get the grips with it, it's a powerful and flexible way of working. Since we are looking at camera, let us edit something that you may be that you may be finding frustrating: the background color of your game view. So here we are changing our background view. So basically camera moves along with the game character. Click the camera and you will see a setting called background in the inspector, which is currently blue. If you select the color, you will be given a chance to set this to new color. So that is how we will change our background. Choose black, that the way your blue squares will stand out a lot more clearly. It is about creating game character. Now saving your project and scene. So how to save our project and scene? Seeing you are probably incredibly pleased with this amazing creation, and it's time you go about saving it to make sure nothing bad comes to it. So now we want to save our project. Now there are actually two things you need to save here: the project and the scene. The scene is what you are viewing through your scene window, and it encompasses everything in your hierarchy right now. That is two squares and a camera. For all extents and purposes, a scene is a level in most cases, though it could also refer to a title screen or an options menu. It is essentially any collection of game objects and scripts that you will want to load at some point in your game. You can also copy and paste game objects by right clicking and selecting copy from hierarchy view. This might feel pretty unexciting at this point, but it is actually a very important skill. When creating levels in games, it's really important that all your tiles are perfectly positioned right next to each other, and that they will do not have a tiny pixel wide gaps between them. So you have to create a perfect game level. That means you should not keep gaps between these tiles. Chapter 4: Adding physics and getting started with coding. So in this chapter we will discuss about adding physics, that is rigid body 2D and box collider, etc. And getting started with coding, that means we are using C hash language here. So that is about getting started with coding. At this point you now have a world that is starting to look a little bit like a conventional computer game. So at this point we have seen basics of Unity, and at this point we have used square box also. That means at this point you have a world that is starting to look like a little bit of conventional computer game level. So by adding tiles, etc., we can create a game. Now in this chapter we are going to make it play like a conventional computer game level by adding some basic physics. So by adding some basic physics, that means gravity, we are adding to character. So that is basic of physics. And movement. So movement is basically we are moving a character. For example, we were using that square. So that square will be run forward or backwards or walk forward or jump, etc. So that is movement. For this you are going to be trying your hand at coding for the first time. Good luck. So we will need coding for this. So good luck. So we have a tiled sprites that have a grassy pattern, and to mix things up a little, I have also created a sprite to represent the ground underneath the grass. So we have created, so we can create different patterns like grass, then soil, etc. Soil tiles, then grass tiles. This is for 2D game actually. So 2D game is less complex than 3D game because it do not have a Z axis. We have only X and Y axis here with my level design. Now we are going to do something even more exciting. Create a game character and drop him into our world. So we are creating a game character and we will call it Squarey, or we can use any character and drop in into our world. Means this character will have some special abilities like walking, moving, etc. And all other game objects which are soil, etc. will not walk, and this character only will have movement. So that is why we are calling him a game character. And drop him into our world means we are putting it into our uh, putting him along with other game objects. Now we are going to make a simple character. So simple character means um, a drawing, simple drawing. So that will be our character. We can use complex stuff later on. Sprites we possibly can, which would be another square. In the interest of making things a bit more exciting, we will give him eyes. So we are drawing eyes on him. So you can use any character or any photograph of a cat, dog, etc. So that will be our character. Squarey can be any size you like, but for simplicity I recommend keeping the same dimensions as you used for ground tiles. So squarey can be any size, that is that means 50 by 50 pixels, then according to grid size. So it can be any size, but for simplicity I recommend keeping the same dimensions as you use for ground. now add query into your sprites folder. So sprite folders are at downside, that means on left side at down of the screen, that is in project window. So in project window we have sprites folder. So in sprites folder we are inserting our character. So query is our character now. So query character is inserted, is in sprites folder now. Just as you did with other, make sure that you remember to set the pixels per unit to 50 again. That means our grid size is actually 50 in Unity. So according to our grid size, we are changing the pixels of our character, that is 50 by 50. So that is why we are keeping per unit 50 again, and then drag it into your scene. That means by clicking on that icon, we are dragging it into directly our scene. So this is one method. So this is the easiest method. So we are dragging our character into scene. Name this game object. So game object player. So this game character is also a game object like other objects which are tiles, soil and grass. So now we have three here game object. That is, first game object was our soil, then second was our grassy soil, uh, soil having with grass on upside. So that was second game object, and now we have a game character. That is, third object is this player, which is squarey. So keep it separate from squares folder. So keeping it separate from square folder. So that is why we created another folder in our into our sprites folder, that was at the bottom of our screen, left hand side. So this was an another folder. So in this another folder we separated this game character from other characters. So we have setup of our character now. Congratulations, you now have a main character. So this main character is a squarey. Problem is he doesn't actually do anything here. So we have not added physics to it, and not added physics to tiles also. That means squares and that means soil and soil with grass. So we have not added physics to that also, and we have not added physics to our game character. So it will not do anything yet. So it is just there, but it is not doing anything. So next thing is to add our physics, that so that gravity and other things will affect our character. So gravity and other things will affect our character means our player will have gravity now. So gravity will work on our player. So we can change our scale of gravity also, that is 6. So if we select gravity as 6 in inspector window, it will drop fast. If we create gravity as 1, so it will be lighter, the character will be lighter, and it will be dropped slowly. And you won't believe how Unity makes this bit easy. That means makes this bit easy means using gravity, adding as a uh, box collider, or having adding physics to it. Basically Unity makes it easier. Now using rigid body 2D. As mentioned, the whole point of using physics engine like Unity is so that we can access ready-made scripts and elements to avoid coding everything ourselves from scratch. This makes it incredibly simple to add something like gravity. So with the help of rigid body 2D, we can add gravity, and it is actually easier without doing any coding. All we have to do is drag a script onto our game object for it to take effect. So we are dropping script into our game object. That means we are going into options, then we are selecting uh, add component, and then physics 2D, etc. So we are dropping that script into our game object. So it is easy with the help of such Unity engine for adding features like gravity. While your player is selected, click add component in the inspector. So we have to select that first that means we have to click on that player, and player, that means game object, that was query. So after clicking on query, we are going to add component in inspector. Now click physics 2D. So then physics 2D, then rigid body 2D. So rigid body 2D is added now. Now rigid body 2D is name of script that works on 2D sprites and applies all basic physics we could want, such as gravity, friction, momentum, collision, and more. So these are adding rigid body 2D is a part of Unity game engine. So this part adds various effects such as gravity, friction, momentum, collision, and more. The easiest way to see what this does though is to put it into action. So drag query a bit higher in the scene window, and then click play. So the easiest way to see what this does is, that means we are now actually performing that physics on that character. So we are dragging him up and clicking play button. So we are dragging our query up, then clicking play button, so it will fall. Now it will fall, so that means that physics is working on it. So it is falling due to gravity, that means physics is working on it. Using colliders, the astute will note that there is something missing here. Of course, we don't actually want query to fall through the ground underneath him. We want him to land on it. Fortunately, this is an easy fix too. So after clicking play button, it will fall, but it will fall below that soil. That means it will not land on slide. So because that soil is a game object and query is also game object, but query has that physics script involved with it. So gravity is working on it and box collider is working on it. But in case of soil and grassy tiles, it it uh, it do not have any kind of physics component or physics script involved with it right now. So we have to add that script to it. Now this procedure is same for adding that script to that tiles and grassy tiles also. Just click query again and then add component physics 2D box collider. So we are clicking so just like we select all icons on desktop at once, we are selecting all those tiles and grassy tiles also, and then we are going into add component, then physics 2D, and we are adding box collider to those tiles. You should now be able to see both rigid body 2D and box collider 2D in the inspector. So that means that tiles are also now added with physics objects, that means physics rules. What you should also notice is a thin green outline around query. So when we add a box collider, so we notice a thin green outline around query. This is the collider which essentially defines the boundaries of your sprites and tells rigid body 2D where the physical mass that makes up character starts and stop. So that means now this green line is telling that character where to start and stop. So this is basically about that box collider script. So box collider tells us that where that character should start and where that character should stop. Click play and you will see that the character still falls through ground below. Hopefully you have guessed already that this is because our time also need to have colliders attached. That means rigid body 2D script is now working. So we had used that script on our character, that was player, but we have not used that script on our tiles. So this box collider should also be attached to tiles. To do this, drag a square around the tiles in your scene view using mouse in order to select them all at once. That means just how we select icons on our desktop, we have to drag a square around those tiles. Now all those tiles are selected. You can do this just the way you would select a bunch of icons on a desktop, or by clicking the first item in the hierarchy and then last item while holding down the shift. So this is another way of selecting those icons, that is holding first item in hierarchy and then last item while holding down shift. So you can use shift also, and you can use mouse also for selecting all the icons. This is a trick that will often come in handy, although there is another method for making mask changes that we will look at shortly. Make sure to deselect the camera and then add a collider in the inspector. This would now be applied to empty game object. So the camera should be deselected while we are selecting those tiles. So make sure to deselect the camera and then add collider in the inspector. This will now be applied to every game object selected. When teams of programmers work together, commenting like this is immensely important to ensure that every member knows what everything does. So that means commenting is also important when several people they work together. So to understand what everyone else is doing, if we pass that code to our different colleague, so he will understand that what comment uh, from comment that what this particular code is about. The two comments that are already here describe what the functions do. The first one says use this for initialization. So in our first program we had a comment that use this for initialization in first line. So void start will run whenever the script is first introduced into scene. So in void start we will introduce script. The second comment says update is called once per frame. So void update runs repeatedly at very fast speed as game refreshes. In this case we need to work with the rigid body 2D script that is attached to our player game object, and to do that we need to add following code. So we are here adding rigid body 2D script. Public class controls mono behavior. Public rigid body 2D RB. Void start RB is equal to get component rigid body 2D. What is happening here is that we are creating a reference called rigid body 2D and calling it RB, short for rigid body. Don't worry if this is a little bit confusing. You can just copy and paste the code for now and it will make more sense later on. Finally, we are going to add the following line of code to our update function. Void update rb.velocity is equal to new vector 2 1 comma rb.velocity.y. So we are adding this new code. Make sure to remember to save your work. Now all that is left to do is to head back to Unity and add the player script to the player character. So we are adding player script to the player character. We do this just the same as we added rigid body 2D. Select the player game object, click add component and then scripts player. Now click play and you should find that query moves continually to right and then falls down two steps to his ultimate doom. So that means after adding these scripts, now we can see the player is working according to it. Only once you have attached the script to your game object it have any effect, and you could just easily have added this to ground tile for the same effect. Introducing variables. Now it is time for us to play with some variables which are very important concept in coding. So variable is an important concept in coding. So now we are introducing some variables, and where a lot of logic and versatility comes in. That means in variables a lot of logic and versatility is included. Essentially a variable is a shorthand for piece of data that can be used to represent that data, such as health or player's name in the future. So variable is used for uh, representing data such as health and player's name. In future, the chances are if you can think back to math at school, you will find you have encountered variables in past. Remember puzzles like this: 10 plus x is equal to 13, then find x. So this was a puzzle which included a variable called x. Well, in this case, x is a variable that happens to represent 3. But if we want if we were to write it like this, 10 plus x is equal to what? We can change the speed that our character moves at by replacing 1 with the variable called move speed. But first we need to define what move speed means by initializing it. So now our code looks like this. So that means we can use a variable for changing our move speed. So this is a code by which we can change the moving speed of our character using Unity engine, using system dot collections, public class player, mono behavior, public rigid body 2D RB, public int move speed. So use this for initialization. Now void start RB is equal to get component rigid body 2D move speed 2. Update is called once per frame void update. So with this code, Squarey will move just the same before, but this time at twice the speed. So Squarey is going to move twice the speed with this script. When we created our variable, I use some terminology that will be useful to understand int. For example, it's short for integer, which is a type of variable that stores whole number. Whenever you define variable, you always need to tell C# what type of variable you are working with. A few useful ones to know at this point are integers, a whole number. Float, a floating point variable, is a number with decimal point. Now boolean, a variable that can be true or false or 1 or 0. Now string, a text variable. Meanwhile, public means that the variable can be accessed from outside the script. In fact, this means that we can even edit our move speed from Unity UI. So we can even edit our moving speed. To do that, delete the line that says move speed is equal to 2 and then select the player game object in Unity. You should see that there is now a move speed box in the inspector. So we don't need script actually. We can use Unity's user interface also to change the move speed. Try setting this value to -1 and you will see the query now moves in opposite direction away from the stairs. So we are uh, changing the move speed now. So if we are setting the value to -1, then you will see that query now moves in opposite direction away from stairs and towards the sudden drop. If you don't delete the move speed is equal to 2 line from the script, this will simply be overwritten every time that a start function is called. So we have to delete move speed is equal to 2 line. If you don't want the variable to be accessible outside your code, then simply use word private instead of public. For now, let us leave move speed is as 3 because we want query to be a bit faster for next bit. Although you could have done this same thing without using variable. This is all very useful to know and you will see it comes handy repeatedly as you add more elements to your scenes. So that means using of variable can be useful also when we have more elements in our scene. Controlling the player character, seeing our character move around the level and interact with the scenery is pretty exciting, but really we want to be able to control the character. So now we have to control our main character, that is player. The good news is that this is something we can do quite easily, but by only slightly changing the code we already have. All we need to do is add couple of if statements in the following code. So here we are adding this script for the moving our main character, that is player. Now void update if input dot get key code dot left arrow in bracket rb dot velocity is equal to new vector 2. Now minus move speed comma rb velocity dot y if input dot get key is equal to key code dot right arrow rb dot velocity is equal to new vector 2 move speed comma rb dot velocity dot y. So what is happening here is that the script is checking to see whether there is an input each time the game updates. Of course, key code left arrow and key code dot right arrow refer to respective keyboard inputs, and then we move the character by move speed or minus move speed depending on which one was pressed. If statement essentially tell a section of code to run only when a specific argument is true. The code inside the curly bracket will run only if line inside the parenthesis is true. So if statements are used for that. If we were to write this in a pseudocode, that is fake code that uses a normal English terminology to be more easily understandable, then it would translate as follows. If the pseudocode, that is fake code for moving character that uses normal English terminology, would be as follows. If player is pressing right, move character to the right. It is always important that you remember the close curly brackets at end of if statement. If you have any experience with Excel and other spreadsheet software using if statement, like this might be familiar. If you click play now, you should have the exciting opportunity to actually try controlling query like real game, although we have had to write a little bit of code here. Hopefully you agree that this is remarkably simple. All things considered, with just a few lines, we now have a good looking game world and a character that we can control within it. More advanced logic and introducing jumping. Query can, so here we are using advanced logic and we are making that player to jump. Query can move left and right like a pro now is pretty adept by jumping off things too. You should be feeling like a proud parent. But in order to platform with the Mario, Sonic, and the best of them is also getting to need learn some jumping skills. So all the games, including Mario, Sonic, etc., they had jumping skills. Unfortunately, that is little more complex than moving left and right. You could try and implement jumping the same way handled moving left and right. The following code would allow our hero to jump. So this is code for jumping. If input dot get key, that is key code dot space rb dot velocity is equal to new vector 2 rb dot velocity dot x comma 5. So this is code for jumping. The only problem is that this code would also allow him to fly. That is because we would be adding more upward velocity every time we press the spacebar, regardless of whether he was on ground or in the air. This is no good. So instead we need to check that he is on terra firma first, and that is the tiny bit more complicated. First we will need to create a new transform. A transform is a point in space that has its own coordinates and rotation, that is angle. This so transform is basically a point in space that has its own coordinates and rotation. This point is also going to have a radius which will be a float, and we will also need a layer mask. We are now also creating our first boolean variable called on ground. So on ground is our uh, on ground we will use, that is our first 1 and 0, that is boolean variable. in short in short, you are adding all the following code to your script: public transform ground check, public float ground check radius, public layer mask what is ground, private bool on ground. In case that was not daunting enough, at this stage we are also going to add another function to our code called fixed updates. So fixed update is a function like update, except that whereas update is tied to refresh rate of the screen, fixed update is more consistent and therefore more reliable for code related to physics. So fixed update is also a function like the on ground. Remember, ground is a transform, meaning a set of coordinates. So ground is also a transform, so it has a set of coordinates. By dropping an empty game object into here, we are now telling our script to set those coordinates to be those attached to check ground. In other words, we have defined a point, and this is how we are going to look at whether or not query is standing on solid ground. Now set the radius value to 0.1, meaning that it will be a very small point. Finally select check ground in scene view and use the move tool to position it just below the query so that it is checking the space directly below him. One more thing we need to do is create a new layer and call it ground. Drag and select all your floor tiles again and then look for the layer menu at top left of the inspector. At the bottom of the drop down you will see options to add layer. You will then be given the opportunity to create your new layer simply by typing its name into next available space. Type ground into empty space, then go back to inspector for your square tiles, and this time select the ground from the drop down menu and select them to that value. So here we are using user interface of Unity instead of writing script. Now view the player game object in the inspector again, and this time set what is ground to ground by using drop down menu. This basically means that anything that is set to the ground layer will now be treated as ground in our script, meaning query can jump off it. With all this done, we can now simply add the final line of code to our script. If input dot get key, now key code dot space and on ground, rb velocity is equal to new vector 2 rb velocity dot x comma 5. Now hit play and you will find that query can jump, but only if he is on solid ground. This means he will not be able to jump continuously in the air, and it means that in chapter 5 we can start introducing some actual performing challenges. A little bit of further explanation, that means in chapter 5 we will discuss about it more. You may still be a little confused that what has actually happened here. Let us recap what is going on. The key is this line which we have placed in our fixed update function. So on ground is equal to physics 2d dot overlap circle ground check dot position ground check radius what is growth. The statement physics 2d overlap circle, that is ground check dot position dot ground check radius what is ground, is a true or false statement. So it is a boolean statement that is asking whether the ground check transform is overlapping with anything that we define as ground, that is what is ground. On ground is true if there is an overlap and false if there is no overlap. Remember, this is a variable that can only be either true or false. Because this line is in fixed update, it's going to continually change its value depending on what's going on in the game. On ground is true if there is an overlap and false if there is no overlap. Remember, this is a variable that can only be either true or false. Because this line is in the fixed update, it's going to continually change its value depending on what is going on in the game. In pseudocode, we are saying this: if the circle underneath the player is overlapping with ground material, then on ground is true, otherwise on ground is false. In Then in our update function, we check whether on ground is true whenever the player presses space in C hash, and simply means so uh, when a player presses space bar, then the on ground function is true. Now and simply means and, that is logical and or not. So according to logic gates, it is and. By using and inside an if statement, we are testing whether two arguments are true. So if input dot get key code dot space and on ground, rb dot velocity is equal to new vector 2 rb dot velocity dot x comma 5 actually means if player presses jump and on ground is true, then add upward velocity, one final touch keeping the player upright. Except there is one small problem: Squarey currently tumbles and spins downstairs as though he had a few too many vodkas. So Squarey is falling. If you jump and then land on your head, you want to be able to take off again because the check ground game object will now be pointing up in the air. To fix this, we have to fix this problem. To fix this, click Query and find the constraint options underneath the rigid body component in the inspector. Here you will find the option to freeze rotation Z. Tick that box and Query angle will now be locked in a place. So now we know that Squarey is in upright position. You will notice a few other options here too, such as gravity scale, which controls how Squarey is affected by gravity, and a few others. We will be playing around with this in chapter 5. Now you can try creating a few floating platforms and having a little fun trying to cross them without falling off the screen. You might need to adjust your jump power a little for that your gravity scale, so just have some fun with it and take a moment now to reflect on what you have already accomplished. Only a short way in and you already have a character that you can jump around screen and level. That is quite fun to navigate. We have barely gotten started, so think what else you will be able to do before we finish. So now we have character which is jumping and which is upright. Chapter 5: Filling the world with prefabs, effectors and collectibles. At this point, things are starting to come together and feel a bit like an actual game. So up to this point, things are feeling like a actual game. We have a very basic 2D level. So our 2D level is basic. We have a character that we can move around with the arrow keys and the spacebar, and we have working physics. So we have a few little movement up to this stage. That means it can move only with arrow keys and spacebar. But a few things are still little off at the moment, and we are not following all the best practices. The world is also rather empty, devoid of any collectible scenery or even a sky. So in this chapter we will add more details in our game now. In this chapter, we will be looking at how we can begin adding things like trees, coins, and platforms that have special properties. We will also see how to keep better track of all these new elements and streamline our game design process with prefabs. By the end of your game, world will look a lot more colorful, and you will even be able to start creating some basic platform challenges. One thing you may have noticed that isn't quite right at the moment is the fact that we can stick to walls. If we run query into wall and keep holding the arrow keys in that direction, then he will glue himself to surface and stop falling. So here we are using walls. So that is pretty odd behavior for a platform game. So let's stop that from happening. First click the platform you want to edit and then view it in the inspector. Now click add component physics 2D area effector 2D. You will then be prompted that you need to tick the box under the box collider 2D that says used by effector. Now try and click on character and stick the character to black, and you will find the simple it simply slips off. In short, platform effector has caused the platform to behave like a platform. Try and jump into platform from underneath and you will notice something else. Squarey can pass through them. You might have played platformers with this feature before, but at the moment we want to turn it off. The reason for this is that as of now, performing this move will break the game. Holding jump will currently cause Query to jump a second time as he passes through the floor, which looks very strange. There are plenty of ways to fix this by using raycasts to check for the ground instead of the system we are currently using, for example, or by simply making the player tap the spacebar a second time before they can jump again. Right now, though, it is easiest just to untick use only one way box, which will allow for some gameplay features like caves and dead ends. So these are new features like caves and dead ends. These are new features. This is a very early example of how your gameplay is going to dictate decisions you make regarding your physics and code. You can not build game engine and design your levels separately. The way the game world behaves should be informed by your game design and vice versa. From form should follow function. In this case, the question is whether you want to design a more fast-paced game that allows the player to seamlessly scale through platforms by tapping jump, or whether you want something a little more puzzle exploration based and maintain the ability to trap them in different sections. More effectors. Effectors are great way to quickly and easily get your game elements to behave in specific ways. When you choose the platform effector, you may have noticed that there were also a few other effectors you could have chosen. For example, you may have spotted Beyonce effector. This is an effector that allows us to make behave like water. So this is a bouncy kind of effector. This is an effector that allows us to make tiles before like water. To demonstrate how useful effectors are, let's design some new tiles that look like water, keeping our same 50x50 dimensions. Now add this to your sprites folder and create a new game asset called water square, or whatever you want to call it. Remember to set the pixels per unit 50 for this sprite and make sure that it has a collider. Now choose add component physics 2D Beyonce effector 2D. Remember to tick used by the effector, and this time you are also going to click is trigger. We will explain what this means later. Copy and paste a few water squares and surround them with banks on either side to create a pool. Now jump into it and watch query bob up and down below. Surface. Other effectors can let you create wind, icon wear, belts and more. So there are other effectors like wind also. Prefabs and more organization. Nope, I didn't forget. Right now we have a pool of water. That's a lot of fun, but only one of our tiles work the way it is supposed to. You could go and change every square tile in the scene in order to apply the platform effector, and actually this would not even be that bad considering that we can select multiple game objects at once and add components or change settings in that way. But now imagine that you have multiple levels, tons of different game objects and huge intricate layouts. If you decide you want to change the value now, all that is going to make life extremely difficult for you. So organization is important. What we are going to do instead is to create a prefab. Prefab is short for prefabrication and essentially a game object with predefined properties. We can drop prefabs into a scene, but they will carry all the ready-made components and values. Better yet, when we change the effector in our folder, those changes will be reflected across every instance of objects in the game. That will let us change our minds about aspects of our game design and able to quickly implement those changes. First, create a new folder inside assets and call it prefabs. This is same process as it was sprites folder and scripts folder. So the process was right click, create, and then create new folder. So as we created the sprites folder and we created scripts folder, the process is same as that. Now comes the scary part. You are going to delete all the tiles in the scene view except for the player and the camera. All that hard work has not gone to waste though, because now you are going to be able to simply drag and drop one of each tile into your game world again. This is a nice opportunity to create some even better organization and redesign our level. Before you start dropping tiles in again, first select the prefabs and view them in the inspector. In here, change the names to something that will be easily recognizable. You can also take this opportunity to create separate empty game objects to serve as grouping for each of the three elements you have on the go. Mine are topsoil for the grass, ground for the dirt, and water for the water. Now, so we have three elements in our game now: soil, water, and grass. Now drag one of each tile back into scene, holding controls snap to grid. Make sure the first instant of each item goes in the correct group so that the duplicates will also appear in here. Start by dragging the item out of the prefabs folder and into the correct category. Then you will be able to simply copy and paste the elements within the scene view. Here you are making copies that will conform to the rules of the prefab. Do not forget to hold Ctrl to space your tiles out and snap them to the grid. Now you can redesign the level layouts as you like. Finally, create one more empty game object and call it tiles or something similar. To demonstrate the power of the prefab, you can now try something like the grass tile in the prefab folder and selecting use one way. Click play and you will find that you can now jump through any instance of grass block from underneath, untick it and they will also all change back. This will make our workflow much easier as we move forward, and so too will the way we have arranged our hierarchy. So this is making our workflow easier. Try clicking the water group for the instant, and you will see that every single water tile gets highlighted. This is about water. Now this means you could easily delete an entire category of tile, and in the future this is going to help us to manage things like collectibles, enemies, and decorative items. Good timing. The next part of this chapter is going to start adding more variety. Troubleshooting helps query keeps getting stuck. One of the joys of software engineering is that things will constantly go wrong, and you will be forced to try and deal with them. Sometimes there will be simple fix, and Google is your friend, for instance. Other times the issue might be outside your control, forcing you to come up with a novel solution. That means in software engineering sometimes issues are simpler, sometimes they are complex, sometimes we can google a few simple problems, but sometimes it is not possible uh, to easily solve those problems. Right now, if you are using box colliders on your tiles and your player character, you might find that you occasionally get stuck on things that you should not. Your character may stop moving and press against the air. The problem normally occurs at vertices between the closely positioned tiles, and unfortunately it seems that this is slight issue with Unity itself rather than anything you can fix. If you do encounter this problem, just try using Polygon Collider for Squarey himself, changing the shape slightly by clicking Edit Collider and creating a small pump in the outline so you can slide over the imagined obstacles. This problem can be solved by using a Polygon Collider. So some problems can be solved, and some problems cannot be. Understanding parents and making a moving camera. One other thing that is useful to understand is the relationship between parents and children. These grouping in your hierarchy are not really folders as such. Rather, the empty game objects are called parents, and the items your groups under them are called children. This is an analogy actually for a game object. So game objects are called parents, and the items your group under them. The items which are under them are called children. Like real parents and children in this case will inherit the properties of adult. So they this analogy is given because these empty game objects, so the things under them, under the game objects have inherent properties of game objects. So this is why that analogy is given. Now for example, you want to move the topsoil to the topsoil, that is we have soil that we have created, that is with grass. So move the topsoil to the right, then all of its children would move right by the same amount, ensuring they all remain within relative distance from one another. Why might that be something you want to do? Well, how about if we use this to stick our camera to our player? Right now, Squarey is only able to explore within the confines of the screen, which is rather limiting the terms of the kinds of level designs we can make. But if we go to hierarchy and select camera, we can drop it onto the player, thereby making it a child of that game object. Now the camera will always move relative to the player. Move it onto the center of the player to make sure it is in a good position. where you can see obstacles from left and right. So here we are aiming that camera on that player. Just note that this is very much a quick back rather than the way we really want to handle the camera. In a finished game, a camera should do much more than just blindly follow the player. Rather, it will speed up or slow down, zoom in and out, and behave differently depending on type of game. So the camera has different functions like speed up, slow down, zoom in, zoom out, etc., and behave differently depending on type of game. This can benefit the gameplay or provide added drama and excitement depending on circumstances. So these functions of zooming in, zooming out, etc., these are adding required drama to game and excitement to the game. Decorating the scene using Z order. Right now our level looks very gamey. It is very clearly a computer game level and does not feel very lifelike, seeing as the only objects in it are clearly platform designed to be jumped on. To change this, we need to add some decoration to make the world feel like living, breathing place. So we will have to add a few the details. So it will look like a living, breathing place. To do that, you first need to create some elements that you can use for both of these images are PNG files and have transparency around the edge. I did this using the free image editing software GIMP, and we will discuss how you can do the same in more detail in this chapter. So basically this GIMP is a image editing software, so you can use this. For now you want to add these into your game as you have done several times before. Put them in your sprites folder. Make sure to change the pixel per unit and make it your game object. Group them under the empty game object called plants. So we are creating plants here. You may want to create prefabs again too, although this is much less important on this occasion as they will all going to look and behave a little differently anyway. Now scatter your plants and trees around the world a little. You can feel free to mix up the size, and it is not important to stick within the grid. In fact, it is good thing to make the positioning look a little random because that will appear more natural. Remove some of the game aesthetics. Try playing the game now, and you will find that when you walk past the bushes and trees, you might go in front of them or behind them. In fact, you might even flicker in and out of view if you have older version of Unity. So we can try playing the game. So we will notice that we are going through the bushes. The problem is that two things are being drawn in the same place and you have not defined which should go on top. To fix this, you need to change Z order, which you do in the inspector by changing the option called order in layer. So order in layer is an option in inspector which we need to use. If you make the number lower, that means the object will be drawn earlier behind the other elements. Likewise, if you make the number higher, that means it will be drawn at the end on top of everything else. My recommendation is to make some of the bushes and trees appear behind query. Set them to -1 and make some appear in front of the query. Set them to 1. This creates an interesting effect where he appears to be walking through thick foliage. Though it is important as you build the game to ensure that this does not become confusing to the player. Likewise, you also need to try and avoid making things confusing For myself, my recommendation is to keep your player as 0 and to use this as your reference point. I also recommend making sure that the tiles will stay in front unless you specifically intend to add decorations to them. You can add as many details like this as you like. Personally, I feel that these little touches make huge differences. So adding these little touches to your game, it makes a huge difference in your game. I recommend getting a bit creative and seeing what you come up with. And of course, now that we are able to add different layers, that means it is time to add in a backdrop, which will make a big difference to aesthetic. I have drawn a cloudy sky and make it fairly large so that it can cover the space with no dark borders around the edge. You can add large images. So for decoration, we can add large images, or you can tile your background. The choice is yours, or we can use tiles as a background, or we can add large images also. Just make sure you never run out of the sky. Obviously, using larger images is going to mean the following for your app. So there is a drawback of also a drawback of using large images to app. First is it takes up more memory. Second is it takes a little longer to load levels. That means when we are using mobile processors, so there is a memory constraint, then there is a processor constraint also. That means it takes a little longer to load these levels. Now set the background to a Z order of something like -10, just to ensure that you never accidentally put something behind it, and create a group in your hierarchy called backdrop. Parallax scrolling with perspective. If you want to get really fancy, you might decide to use another extra trick, parallax scrolling. You may have noticed that the inspector allows you to change not only the x and y coordinates of objects but also the z coordinates. The simple answer is that under some circumstances, you may want to change the z position of an element in order to create 3D effect. To demonstrate, select the backdrop you just created and change z coordinates in inspector to 3D. Now select the camera and in the inspector click the drop down menu called projection. Change this from orthographic to perspective. Now click play and see what happens. You should find that sky now appears further away and moves much more slowly than the rest of the level. You just created a parallax scrolling effect. So this was a parallax scrolling effect. The best way to illustrate what is happening here is to switch the scene window into 3D mode. Click the 2D button along the top to toggle between the two modes and you should see something. So you can toggle between 3D and 2D mode also. In short, we now have a 3D perspective looking head on at a purely 2D elements arranged in a 3D space. There are a lot of cool things you can do with this, and you can add as many layers and elements as you like. You could even have translucent clouds passing in the foreground or rolling hills moving at another speed in the middle distance. Adding collectibles and hazards. Now that you have added some inanimate objects and decoration, so we have added some objects for decoration, it is time to consider adding some elements that you will actually be able to interact with. So with along with the objects which are decorations, we will add some another objects, that means which are interactable like coins etc. When we touch them, so it will be added as a collectible. So that means adding some elements that you will actually be placed, that you actually be able to interact with, such as coins, etc. And a good place for us to start would be with some collectibles. So collectibles means things which you can collect. So these are collectibles. To do this, we of course need to start by designing something that we can collect. So we are designing something that we can collect, that means coins, etc. So we are collecting that. A popular choice in this regard is gold coin. So let us start with that. So gold coin is popularly used. So let us start with that. Now we are going to once again add it to our scene the way we have added other game objects to our scene. So other game objects were soil, then soil with grass, then that squarey character that was our main character, etc. So we are going to once again add it to our scene the way we have added other game objects to our scene. That means we need to import the sprite. So we are importing this sprite. Set the pixels per unit and then make it into a prefab. Any coins we scatter around our scene, we are going to put into the following hierarchy: collectible, coins, gold coin. So we are adding the gold coins under this hierarchy, that is collectibles, coins and gold coins. This time we are also going to create a collider though, and we are going to tick the is trigger box in the inspector. A trigger is basically a collider that does not act like physics object. In other words, our coin will not be something we can walk into or jump off, rather. So we cannot walk into our coin, and we cannot jump on coin. So this is a different object. We will pass right through it. So we will pass right through that coin, and though it were made of air, though it were made of air, like it is made up of air. At the same time though, Unity will flag up the fact that this had happened, allowing us to add code that tells the game how to respond to this event. Now we need to create a new script, which you should remember how to do. Head down to your assets scripts folder, right click and create C hash script. So we are creating C hash script here. We will be working in C hash language. Name this collect coin. Script names cannot have spaces, and double click on it to open Visual Studio for just a little more coding. In here we are going to use a function called onTriggerEnter2D. This function is called anytime the attached game object is triggered, so anything you have placed in here will happen once the player touches the game object. In this case, we want the coin to disappear, so we need to destroy it. We do this by saying destroy game object. When using Unity, game object within a lowercase g refers to specific game object that the script is attached to. So here we are adding coin which will be destroyed, and for that we will write a script in C hash. So the full script should look like so: public class collection mono behavior. So this is for initialization. So in comments we are writing use this for initialization. Now void start update is called once per frame. Now void update private void on trigger enter 2D collider 2D other. If other dot tag is equal to player, destroy game object. In pseudocode, this is saying when something comes into contact with the 2D collider, if that thing has the tag player, self-destruct. As you may have already guessed, that means we now also need to hop into Unity and add that tag to query. Select query and then find the tag option at top of the inspector. So here we are adding that destroy tag to our game character also. Finally, do not forget to attach the collect coin script to your coins. Do this by clicking add component scripts collect coin. What if we want to create some hazards? In that case, we could do the precise same thing, except we had want to move our player back to the starting position or possibly end the game. Now add the sprite and make a prefab just as you have done before. Remember to set the pixels per unit and then add a polygon collider. So for more precise collision, we can add a polygon collider. You will probably need to shape it yourself to fit around the spikes nicely too. So this collider is a tool which has more options for precisely shape according to our object. You will be adding a script just like last time, and the code will be very similar this time around 2 with a slight twist. Now it will say the following. So this is script for adding a collider to player, that is a main character. Public class hazards mono behavior, public player. Use this for initialization. Now void start player is equal to find object of type player. Update is called once per frame. Private void on trigger 2D collider 2D other. If other dot tag is equal to player dot transform dot position is equal to new vector 2 minus 6 8. Attach this script component to the spikes prefab. Remember to tick each trigger and then you are good to go. This script works very similarly to last one, except instead of destroying the game object, we are moving the player. First we have to define what we mean by player, which we do by looking for objects attached to player script. From there we can then change the transform, that is position of the player, to a new vector 2, a coordinate with 2 axes. We are moving the player to position minus 6 8 because that is where query starts out in my scene. Now when you hit play, falling on the spikes should automatically teleport you back to the starting position. That is not very glamorous, but it does the job and illustrates the point. In the future chapters we will look at how to kill and respawn the player properly, as well as how to tally up points for collectibles. For now, though, this gives a very good idea of how you can use triggers in order to make all kinds of effects work. So that is basically about adding the destroy effect to player and how it goes into first initial level after its destruction. Introducing enemies. Essentially all enemies are hazards that move. You know the drill by now. Start out by creating a new sprite, ideally something that looks a bit menacing, that means looks a bit cunning. Give him a collider, make him a trigger. So basically we have to make a enemy here, give him collider, make him a trigger, and create a prefab. Then attach as a hazard script so he is functionally the same as the spikes. Now we are attaching a hazard script to it. Take a read through that and see if you can work out how it works. Got it? Of course you did. But just in case, essentially we have two public variables that we can set from the inspector. The speed called the speed and the distance that the object will move called amount to move. When the object is created at runtime, it also checks to get its current x coordinate. So x is a variable here. The direction can be 1 or 0 and like all integers it's set to 0, the default when script starts. So the script then asks if the current position is smaller than my start point plus the distance I have to move to right at speed, but only if I am moving right. Once the object goes past that point, that means uh, bigger than or equal to. So this sign means bigger than or equal to. It will then change the direction to 1. When the direction is 1, the reverse logic is applied until the character is equal to or smaller than start position, at which point direction switches back to 0 and we go right again. Now if you add this script to the bad guy along with the hazard script, you should have a game object that moves left and right and kills the player when it comes into contact with them. Notice how you can achieve impressive results without having to rewrite out lots of code. So without writing a lots of code, we can achieve impressive results. Just combine multiple scripts in unique ways. The sky is the limit. So we are combining the multiple scripts. Now pushable objects. While we are adding all these different kinds of objects and elements, let us add one more that is really nice and simple, a pushable crate. So here we are creating a crate or a box which is pushable and which is movable. All you need to do is introduce a game object that has a collider and rigid body, just like the player. This will then allow you to interact with that object by pushing it or even dropping it into your water. So we can push that object and even we can drop that object into water also. This creates a lot of potential gameplay mechanics and challenges, and it could not be simpler. Remember though, if your character is going to be able to jump off the crate, they need to have their layer set to ground. Now using materials. Before I close this chapter, let me address one small thing that still is not quite right with the object in our game world, the slidiness. You have probably noticed that Squarey likes to slide around all over the place like he is on ice. So we have introduced the slidiness, which does not look right and is rather hard to control. To fix this, we are going to create a material and apply it to topsoil. So we are creating a material and we are applying it to top of our soil. To do this, you are going to create a folder called materials and then new physics material 2D RMB, that is right mouse button, then create, then physics material 2D, call this ground. Now select that material to view it in the inspector and you will see that you can change two properties, bounciness and friction. So this material has friction and bounciness. As you might have guessed already, friction controls how much friction a particular surface has. Change this to 0.6 for a bit more ground control and bounciness to 0.1. So here we are changing friction and bounciness. For an imperceptible judder when Squarey lands, now select the topsoil prefab and in the inspector and find the material option beneath box collider 2D, not the one under sprite renderer. Choose the ground material you just created and it should automatically apply to all the grassy tiles in your game. Try running and jumping now and things should be easier to control. Materials like this provide a useful way to add properties to various game objects and we will see more uses of them later on. So these are properties which we apply on various game objects and these are useful properties. Chapter 6, adding animations, effects and a HUD. We are going to add few more touches that we will give us the foundation of our future game development. So we are adding a few more touches, means we will adding few more details. Touches like animations, particle effects, and heads up display, that is HUD. When we get to chapter 7, it will make sense why we did this first. So these are additional details, which are animations, then particle effects, and heads up display. These are additional details. And don't fret, there is a lot to be excited about right now too. Adding simple things like animations is what will allow you to really add character and charm to your game and elevate it to a point where it starts to look like really rather professional. So charm means it will add excitement to our game. It will make our game look more professional. So these are important effects. Handling death and using particles. Everyone has their own way of handling their mortality. So we will here we are programming about death. That means how to destroy that player character, etc. using particles. So everyone has their own way of handling their mortality. Right now, Squary's way is not particularly elegant. Not only not only does he just kind of appear back at start of game instantly, but he also does not give us any brief pause while that happens. So it is going to it is appearing back at start when at uh, at starting of game, so after his death. So this is not so much interesting. We will add an effect called particle effect for death. The whole thing is a little too brief to let it really sink in. So the whole thing is little too brief. That means this is really difficult. It would be nice if we had some kind of death animation, or better yet a gory explosion. That means uh, if we get some kind of death animation, that means uh, the animation for death, that is destroying or particle effect, etc. To do that, we are going to use particle system, an effect that lets you scatter pixels all around the screen and get them to behave in different ways. We are going to make a particle effect that will look like an explosion of blood. But you could just as easily use this to make regular explosions, fireworks, fountains, electricity, and more. To create your first particle system, choose game object, then particle system. You should see a fountain of slow moving white blobs in your scene with options on the right hand side in the inspector. You need to tweak some of the setting here in order to make effect look like blood. We can start by changing the start color to red, that is click the white bar and start size to 0.02. Then click the shape option below that and choose the sphere instead of cone. Under emission, change rate over time to read 300. So here we are creating the blood explosion effect. Now expand the renderer menu option and click the circle next to material option. Choose sprites default and the red blobs should change change to red squares. Next, expand size over lifetime. Note that you need to tick the bullet box first and drag the right hand side so that line is downhand slope, so that the line is down. This means the particles will get smaller as they travel through air. So this is about effect also. That means the particles will get smaller as they travel through air, allowing them to disappear. So these particles are disappearing in a way that looks natural rather than suddenly blinking out of existence. Similarly, you can also do the same for color over lifetime. I have made my blood get slightly darker as it expands outward just to keep things interesting. I also applied point to gravity so that the particles fall downward. Feel free to play around with other options as you want. They are generally pretty self-explanatory. One thing you need to do though is to untick the looping box at top and change the duration to 0.30. Now the effect will play just once and end rather than looping instantly. At any time, you can still test the animation by clicking the simulate button and floats over the scene view when particle effect is selected, destroying the particle system. We are going to put this to one side of for the moment. Now, while we write another new script, create this in the scripts folder as ever and call it destroy particle system. Can you guess what it is? So here we are writing script for destroying particle system. This is code for destroying particle system using system.collections.generic, using Unity engine, public class destroy particle effect mono behavior, private particle system, this particle system void start. This particle system is equal to get component particle system void update. If this particle system dot is playing, return then destroy game object. So this is script for destroying particle system. The purpose of this script is simply to destroy the particle effect once it has finished playing. First we look for the particular instance for our particle system, which in object oriented programming is often referred to as this, and then we check to see if the particle system is playing during the update method. Finally, once the effect has finished playing, we destroy it. Why is this important? Because otherwise we would have countless instances of our particle held in memory, which could eventually start to bag things down. This will make a little more sense in moment. For now, just take my word for it, save the script and add it to the component to particle effect object. Making hazards hazardous. We are not quite done yet though. Next, you need to add additional code in your hazardous script which look like so. Public class hazards mono behavior, private player, public game object blood, void start. Player is equal to find object of type player, then void update, private void on trigger enter 2D, collider 2D other. If other dot tag is equal to player, instantiate blurred player dot transform dot position player dot transform dot rotation. Player dot transform dot position is equal to new vector 2 minus 6 8. First we are looking for a public game object that will be referred to as blood, and then we are instantiating the game object. Make sure you also remember to set the blood prefab as the game object in the hierarchy for each of the hazards. You need to do this in the prefab folder so that it will be reflected across each subsequent instant of spike or an enemy rather than just that particular one. With all that in place, you can now try playing game and testing the new effect. Only try watching the game as it plays in the scene view rather choosing the full screen game view. This way you should be able to see what happens when Squarey walks onto the pit of spikes. He explodes and an instance of blood particle effect is created at the location. And that is why when needed the destroy particle effect script, otherwise we would have a lot of finished particle effects. So that is how this destroy particle effect is working, all in the hierarchy from all the times we died, and this would take up unnecessary memory. We can likewise use similar scripts if we create bullets or enemies, so data is destroyed as we use it up. In this case, we might have a script that destroys objects after a set amount of time or after a certain interaction with the player. Why not try doing something similar for coins in your game? Create a new particle effect and call it sparkle. Make sure to add the destroy particle effect script and then apply it to coins in the game. Do not forget to add necessary line collect coin and script either. So here we are applying the same effect to coins also. Two more added touches. We are going to add two more little touches to our handling of death. The first is to introduce a short pause between Squarey being killed and Squarey appearing in his new location. So we are adding animation for the player's death, that is Squarey. When he is dead, so we will add a different animation. And when he appears again, then we will add another animation. Respawn delay is a routine that can occur while things are going on, which means we can include a pause without making it look as though the game has crashed. Respawn delay is basically delay for making that character live again. So that is respawn delay. So it is a routine. We are instantating our explosion waiting for 1 second. So we are waiting for 1 second after the character's death. Now then moving the player to new position. Then we are moving that player to new position. Between these events, we are also turning off the visibility of our player. So when the player is getting killed, we are also turning off the visibility of our player. So which is turned off by player.get component renderer enabled false. We are removing all momentum so that the player won't be moving when they respawn. So we are removing all momentum. So which is done by script player.get component rigid body 2D velocity is equal to vector 3.0. Hit play and give this a try. You should find that Square's death is now a little more convincing as he explodes. The game pauses and then appears back at start. In an upcoming chapter, we will be taking a look at how to implement checkpoints, but for now, this should do the trick just nicely. The last little touch we are going to make for now regarding death is to stop Squarey from falling infinitely when he drops off the edge of our level. This is very easy to do. All we are going to do is to create invisible game object. So we are creating an invisible game object here with a box collider and attach the hazard script. Then we will stretch it out to create a barrier underneath the level. Remember to make sure that the game object is a trigger. Now animating the player. Adding particle effects like this has done something important for our game. It has added a basic animation which makes the world feel much more dynamic. But not every animation involves lot of little dots being scattered all over the place. In a conventional platformer, objects are animated like cartoons, so they look like they are really running, jumping, or blowing in the wind. So, Squarey is also a game object, but in the conventional games, the objects are animated like cartoons, so they look like they are really running, jumping, or blowing in the wind. It is high time we added this kind of dynamic animation to our player character. So with that in mind, I have created a little spaceman who can explore the alien worlds we are going to be designing. We call him a Kevin after the Kevin Spacey. So that means Squarey is our character. That means we added one square, but people prefer a cartoon like character, so we can add any cartoon like a spaceman, etc., so that they will appear like they are running. You may have noticed that Kevin's sprites is little different from your regular sprite. Specifically, Kevin is not one sprite but several sprites. Except all those sprites are in single file. So that means there are a lot of sprites, that means objects like Kevin sprite. You can either use Kevin in your own game, or you can create a different set of sprites. Just be sure to keep them all in one image file. This is simply a more efficient way of handling sprites, and you can likewise make sprite sheets for any elements in game. Import this into game as you usually would be, then open it in the inspector, and after seeing the setting pixels per unit to 50, set sprite mode to multiple. This slice button is great because it automatically detects all the frames in our image and crops them for us into multiple different images. You will see the individual frames outlined by boxes, and you will have option to adjust this manually. If you prefer, once you are happy, just click apply and along the top. Now you can select the first image from sequence in your sprites folder. Clicking the little arrow next to sprites will show the individual frames, and drop it into the sprite box for player character. Now we have replaced query with Kevin. So here we are replacing our main game character, that was query, with Kevin, but he will still kind of slide along the floor when we run. So that sliding effect is still there. As the next step is to open up two more windows in Unity. These are the animations and animator. You will do this by selecting Windows Animation and then Window Animator. Using the top menu, this will open up two new windows that will be floating on top of UI starts with. You will see I have selected the player, which you should do too. In the animation window, you should now see a create button, which we will use to create our first animation. So create button is used for creating animation. You will notice that once you have done this, a timeline appears in the animation window along with a kind of mind map in the animation window. We will get to that in a second. For now, all you are going to do is drag and drop the first sprite of Kevin standing completely still into the start of the timeline, so that you have an idle Kevin. Believe it or not, you just created your first animation. It doesn't feel like much of an animation, seeing as it only has a single frame. But if you watch the animation window while the game is playing, you will see the game same image is looping over and over. Walking with the animator. Our more interesting animation, of course, is going to be the walking animation. To make this, you need to find the word idle in the animation window with the up and down arrow next to it. It's in the top left. Click that and then click create new clip. Call this one walking, and make sure it is in animation folder again. So here we are making the animation walk. What we need to do is to add a condition under which our flowchart moves from idle into walking. To do this, right click idle and choose new transition. This will create an arrow that you can drag onto the walking state. Now your chart goes entry idle walking. Make sure the transition itself the arrow is selected and then find the little tab that re-adds parameter and switch to that. You will see a plus button next to name, and if you click that you will be able to choose from different types of variable. Remember, variables are containers that represent data like numbers and strings. We are creating a new uh, tool short bool, that is short for boolean, a variable that can be either true or false, 1 or 0. Now code for animation. We need to do a little coding again now. So open up the player script and create a new animator reference which will call anim. Then we are going to add a little code in the update method that will check to see if either the left or right keys are being pressed and set walking bool appropriately. This is code for animation. Public class player mono behavior, then public rigid body 2D RB, public int move speed, public int jump power, public transform ground check, public float ground check radius, public layer mask what is ground, private bool on ground, private animator anim. Void start RB is equal to get component rigid body 2D, anim is equal to get component animator. So this comes under void start section. Now void fix update on ground is equal to physics 2D dot overlap circle ground check dot position ground check radius what is ground. Void update if input dot get key code dot left arrow rb dot velocity is equal to new vector 2 minus move speed comma rb dot velocity dot y anim dot set bool walking true. So it comes under void update section. Else if input dot get key code dot right arrow rb dot velocity is equal to new vector 2 move speed rb dot velocity dot y anim dot set bool walking true, else anim dot set bool walking false. If input dot get key code dot space and on ground rb dot velocity is equal to new vector 2 rb dot velocity dot x jump power. Notice we are using an else if statement. When this statement follows immediately after an if statement, it means that following code runs if previous statement is false and then following statement is true. We could alternatively do something similar with the line anim.setBool walking rb.velocity x 1 is equal to 0, meaning that walking variable will equal true if the statement that follows is true. If the velocity of player along x-axis is 0, however, this can leave Kevin jogging on spot while he slides towards pure momentum. With that done, return to Unity, select the transition that goes from idle to walking and find the heading that says conditions in the inspector. Click plus use the drop down menu to choose walking as the condition and to set a value to true. This essentially means that transition will occur as long as walking is true. Untick the box that says has exit time while you are here. That means that Unity won't wait until the whole animation has played out before transitioning from one to the other. Now repeat these steps in reverse so that you have a transition going from walking back to idle whenever walking is equal to false. As you may have already gathered, there is nothing to stop us from adding more branches to our flow diagram so that the character has animations for jumping, falling, etc., or any other actions we add later in the game. Likewise, we could add animations so that trees blow in the wind and coin spins in the situ. Water could even wave gently on top layer. Flipping Kevin. Of course, there is one rather glaring omission here currently, which is that Kevin only has an animation for running right. Oh no, we forgot to create sprites for running left. Psych. Fortunately, there is no need for us to make everything twice, as we can easily create animations for running left by simply flipping the image when Kevin turns around. To do that, we need to create a private integer variable in our player script and call it facing. Set facing 1 in the start method. It makes some sense to have the forward direction correspond with the positive value, so 1 is going to right. Then update this section of code in update method. If input.getKey keycode.left arrow rb velocity is equal to new vector 2, that is minus movement comma rb velocity dot y anim sort set bool walking true if facing is equal to 1 transform dot local cell new vector 3 minus 1f 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 facing is equal to 0 else if input dot get key code dot right arrow rb dot velocity is equal to new vector 2 move speed rb dot velocity dot y anim dot set bool walking true. If facing is equal to 0 transform dot local scale is equal to new vector 3 1f 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 facing is equal to 1 else anim dot set bool walking false. The keylines here are one that read transform dot local scale. This is the one that is flipping the player sprite by setting the scale to 1 or minus 1. We also need to ensure that we are changing the value of facing so that this only happens the first time the player changes direction each way. Now hit play and you should find that Kevin has a nice little running animation and can switch direction. Make sure that your camera object has a coordinates of precisely 0 and 0, otherwise the view will uh, move slightly as Kevin flips right and left. Of course, this is far from perfect right now. We are lacking animation for jumping. The moment is a little still and the camera is rigidly following us the screen. Don't worry, you can fix all this later. For now, I am just giving you the nuts and bolts so you can start playing around yourself. Feel free to start animating all your game elements. Adding a hood. In other words, it is time that we started letting the player know how they are doing at the game we have made for them and keeping a tally of things like the level, their score, and so on. This will be accomplished by a hood that shows the player's important details. Later, we will be able to use this overlay to show all kind of other things too. So, this hood tells player its performance, its current performance. Now we are going to open up our collect coin script and add a reference to player. Then in the on trigger enter 2D event, we will add the line player.coins plus plus. This is shorthand for player.coins is equal to player.coins plus 1. In other words, we are increasing the value of player's coins by 1. The whole thing will read as follows. Public class collect coin mono behavior user use this for initialization. Public game object sparkle private player void start player is equal to find object of type player. Update is called once per frame void update. Private void on trigger enter 2D collider 2D other. If other dot tag is equal to player dot coins plus plus instantiate sparkle game object dot transform dot position game object dot transform dot rotation destroy game object. If you try playing the game while watching the coins variable in the inspector with the player selected, you will see it goes up each time we collect a new coin. So basically now that collector is updating, that means it is a variable of coin variable, it is updating now. We now know the number of times coins are collected by the player, but at the moment the player does not, so player is not knowing this. To rectify this, we are going to create something called canvas. So we are creating a canvas. Adding and using canvases, head up to that top menu again and create a new game object. This time select game object UI canvas, double click it in your hierarchy and you will see the scene. Suddenly zooms out to show you a large white box. This is canvas, which is where you can add UI elements to your game such as HUD and touch controls. So that means we are creating a canvas here. That incidentally is why it was pertinent to focus on graphics before creating your first APK. So we are here learning to use this canvas. Now right click the canvas in your hierarchy and choose UI text to create a new text object. Here let us write level 1 in inspector and set font size to 2D 20 and bold. So here we are changing text size. The most important thing we need to do at this point is anchor this UI element to top left of the screen. Do that by clicking the picture of the square in the left of the inspector and then selecting the top left option from drop down menu. Rename the text object as level. Then create another one that will be positioned just below the top one called coins. Use the same size color font and make this one say coins 0. Guess what? It is time to make another script. This one will be called score and it will be attached to coins object we just made. It will read as follows. So we have to create a script for a score. So this is so we will create another script called score for collecting the score. It is time for making another script. This one will be called score and it will be attached to coins object we just made. It will read as follows. So this is a script for coin. Using Unity engine, using system.collections, using Unity engine.ui, public class for mono behavior, text coins, private player, use this for initialization, void start, coins is equal to get component text, player is equal to find object of type player, void update, coins dot text is equal to coins plus player dot coins. Notice the line that says using Unity engine.ui. This basically tells Unity that we are referring to an additional class in order to gain more options to code with. The rest of the script is hopefully self-explanatory. All we are doing is repeatedly updating the text, which is type of string variable, to read coins and then the player.coins integer. Adding this as a component to the coins text object and you should now find that the game lets you know how many coins Kevin has collected as he goes about his adventures. So now we have added successfully the script of coins. Now adding a sound effect. As we have done all that, we may as well as finish the job and add a little sound effect to play as we are collecting coins. Fortunately, that is rather easy to do. You will of course need a file that you can use for your sounds, which you can get from the resources included with this book or make it yourself. And as you probably expect, so you can create we can create our own sounds actually also. And as you probably expect, you will want to add this to your new folder called audio, my audio file. I named it as a blink.wav. So we can use any audio file. For example, if a coin is falling, so it make noise, so we can record that audio and we can add for collecting coin. Now add a public audio source blink to your collect coin script, and just above player coins plus plus add a line that reads blink.play. What I have seen a lot of people do is add the audio file to empty collectibles game object, that is a parent of coin object, and then drag it into the box in the inspector. Make sure to untick play on awake. Unfortunately, you need to do this for the in-game instances of the objects, not the prefab. There are other ways of doing this, but for now it will play a sound every time you pick up a coin. Some advanced theory, classes, objects and methods. Oh my, just what is an object? You may have noticed that I refer to pretty much everything in Unity as game object. That is because an object can also refer to a type of data in a programming language. One of the other things that makes Unity so powerful and convenient is the fact that it uses object-oriented programming (OOP). Objective versus imperative versus functional. Imperative meant that everything you wrote was sequential and you would write statements in order that they were to be executed at runtime. The computer would read your code just as you would read an essay from top to bottom. The only exception was when you used the command goto, which would send the interpreter backwards or forward to specific line number in code. Objective versus imperative versus functional. Imperative meant that everything you wrote was sequential and you would write statements in order that they were to be executed at runtime. The computer would read your code just as you would read an essay. So that was imperative programming. So imperative programming means computer will read this code sequentially except for a go to statement. So like reading, this is like reading an essay. The only exception was when you used the command goto, which would send the interpreter backwards or forwards to specified line number in code. So this goto statement will redirect us in a specific line in code for doing that task again and again. This was very straightforward to understand, but it also became impossible to manage as programs began to reach millions of lines, which happened a lot. Then procedural programming came along, which solved some of the issues by containing sections of code in discrete sections called procedures or subroutines. So there were procedures and subroutines. This meant that certain instructions could be called on over and over again and edited separately from main code, but seeing as you had to call the procedures, the code would still be taking a long winding journey and making countless stops along the way. This is what is referred to as a spaghetti code. Classes and object explained. In OOP, subroutines are replaced with classes, which in turn are used to describe objects. An object is a collection of data with properties with behaviors called methods. Our collection, our collect coin script, which is really a class called collection, describes the behavior of coin to disappear when collected. So coin is getting disappeared when it is collected. To increase the player coin's value and the properties, the position of coin, its size and so on. The class acts like a blueprint and can create as many coins, that is object, as it want just as blueprints for a house can be used to create a lot of houses. So this one single blueprint of these coins can be used for creating a lot of objects, just like a blueprint of one house can be used for creating many houses. Similarly, blueprint of this that is coin object, it can be used for creating many coins. We call those instances of objects. When we destroy our coins, we are destroying instances for those coins rather than class itself. A class need not to be attached to a sprite at all either. So class is not needed to be attached to a sprite. A class can also be used just for crunching numbers and manipulating other classes. You could write a script that is class to control the time limit. For instance, and the object in this case would be the time limit, an abstract concept rather than something you could move around, but it is still an object and it's still defined by the class. So object is defined by class. This is also what happens when we tell Unity that we are using certain classes at start of each script. These are classes provided by Unity that provide additional functionality and that we can access these methods and properties of. When we write those lines, we are telling Unity that we want to access some methods and properties that it has created for us. The benefits of going double OP in Unity. So double OP stands for object oriented programming. Therein lies the brilliance of object oriented programming. It allows us to share elements between programming languages and code in modular fashion. So there is a benefit in using object oriented programming. Using objects allow us to borrow elements from other programmers and implement them in our own code. So we are borrowing elements from other programmers and we are implementing them in our own code. This also lends itself perfectly to more open source and collaborative form of development. So this is allowing us to perfectly move to open source and collaborate form of development, which is good for software industry as whole. For us, double OP also lets us keep things neatly organized in logical chunks rather than having one huge file that determines behavior of everything in our game world. Instead, we have game objects all with their own script. Unity helps make things even clearer by giving a visual representation of those game objects and keeping most of complicated stuff hidden. On, on other hand, it is much more complicated, largely owing to need to get your head around classes, methods and objects. In Unity, objects really are objects much of the time and we can literally move them around within our project as tangible units. Unity is a perfect introduction to game object oriented code. Then we then when you eventually make the transition to a less visual type of code, will help to imagine your classes and object exist in a similar way. Hopefully, if we were being pedantic, it would probably make more sense for us to put our code for dying in the player script rather than the hazard script, which are really classes. Dying is a behavior of a player, and so it makes more sense for it to be method of that class. Remember, classes describe objects and behaviors. To do this, we would simply move the code over public method. and make necessary changes, then we would invoke that method from within hazards by writing player.dying. When code gets larger, though, when you are working as a team or when the game is more intensive, being as elegant as possible in your code starts to pay off. Chapter 7, Making an Android App. Our game is still far from complete at this point, and over the next several chapters, you will learn how to add things like levels, checkpoints, menus, more UI elements, and host of other features. So our game is ready, but it is not fully completed. So it will include a lot of other stuff like levels, checkpoints, menus, UI elements, that is user interface elements, that is buttons, etc. So we have to add that. But what we do have is basic game that now works as a game, and it's something that is certainly playable. Our canvas is in place. That means we do have a game that is working technically. Adding touch controls. Before we begin building an APK, it is a good idea to add touch controls. Right now, you could use your app on Android device with a Bluetooth keyboard. You want them to be able to play it with just their phone. So right now, if you install this app on an Android phone, you still can play without any touch controls with a Bluetooth keyboard, but not everyone has that accessory. That means not everyone has that Bluetooth keyboard. They have to purchase that Bluetooth keyboard uh, from uh, external sources. That means they have to buy that Bluetooth keyboard. So which is not possible for everyone. So we want them to play game on their phone with just their phone. Fortunately, adding touch controls is not too complicated process. So adding touch control is not very complicated process. If we were making an endless runner, adding touch controls would be incredibly simple. In this case, all we have uh, all we have to do, or all we would need to do, is this line input get mouse button down. We were using for jump. So for endless runner there are few controls, so it is easy for an endless runner to add these buttons. For example, in an endless runner like Subway Surfer, we are just swiping up for that character to jump, we are swiping down for that character to bend, and for uh, going right and left, we swipe it like a left, and then we swipe right. So for an endless runner it is easy to add those buttons. Designing the controls. The first thing you are going to want to do is to design some touch controls. So we are designing some touch controls to look the part when placed on top of your game. So these touch controls are placed on our screen of our Android phone. If you make your buttons read red or green, you will find that they sometimes look ugly against the game world. So you can use color for those buttons, but they will look ugly because they will not match with our game world. That means games design, it will not match with that. So we are making the game controls, that are game control buttons here. So we can make them red or green, but they will look ugly according to against the game world. For these reasons, I am making my buttons light gray with a thin slightly darker gray outline. So we are making buttons with which are opaque actually, so they will look they will match with the game world. And we are making buttons light gray with a thin slightly darker gray outline. So this is gray color is generally opaque color, so which goes with game world. I also applied a pixelized filter with the image editor GIMP and set opacity to 80%. So opacity here is important because we should see through the world, see through that button, and set opacity to 80%. The result should be something that will not look too distracting and won't feel out of place. So that result will not feel distracting and it will not feel out of place. First is an arrow and second is a button. So we are designing these two things. First is an arrow and the second, this is a rectangle which is button. Adding our controls. Now we need to add this to our game and make do something. First, add the images to your project sprites folder, just like you would you would any other. So we are adding these controls in our game. Now right click in your hierarchy somewhere underneath your canvas. You want this new element to be child of the canvas. Game object and select UI, that is image. An image will appear in your game that will probably look like a big white square. So we were adding those two buttons, which were first was arrow and second was a rectangle. So these two buttons are looking like a big white square. Drag and position the arrow so that it is in the left hand corner of the canvas. So we want to add those go to right button and go to left button on left of the canvas, that is left of our Android screen, which will probably appear massive at this point. So it is appearing massive because the size of that button is large. And then change the horizontal scale to negative numbers so that the arrow points left instead of right. In other words, change the width from 1 to -1. So we are here adjusting width also so that it will fold back in on itself. So we are adjusting width here. Depending on how large you drew your arrows, you will need to play around to make sure that these images are right size. You can tweak this later on once APK is running on your phone, but for now I have mine set to x is equal to -2 and y is equal to 2. So here we are adjusting position of those two controls. Now do the same thing for second arrow. This time the position will be slightly to the right and anchor will still be bottom left. Of course, the scale is going to be in positive figures this time. After that, you can add the jump button, which will be our generic button image. This one will be anchored to bottom right of the screen. Unity does not know what size the phone screen or whatever device you will be playing on is going to be, and thus canvas is likely to be set a bit of an odd shape. So Unity doesn't know where that game is going to be used, or like on Android TV or Android smartphone. So the uh, canvas is of odd shape. Unity does not know what size the phone screen or whatever device you will be playing on is going to be, and thus canvas is like to be a bit of an odd shape. But as long as jump button is set to be a certain distance from right hand corner, and same goes for arrows and the left hand corner, they should be correct position once you hit play. So these controls should be on the correct position. Of course, for a preview, you can hit play and see how it looks on your computer screen. So you can hit play and you can see uh, how it is looking or how it is performing. When positioning of your arrows, it is worth leaving a little space around the edges in order to make sure they are not too cramped. So these arrows that is for left, going to left and going for right. These arrows should be separated from each other. Coding the controls. Right click your canvas, choose create empty and then anchor this new object to bottom of the screen. Click stretch so that it becomes as wide as screen and then drag the elements into here in the hierarchy. Call your new control container touch controller. So this is a container called touch controller. Head into your player script and we are going to add two public booleans. Remember, bools are variables that can be either true or false, that is 1 or 0, and because they are public, they are accessible by other classes scripts in our game. These new variables are going to be called move right and move left, and you are going to use them to do this. If move right rb.velocity is equal to new vector 2 move speed comma rb.velocity.y. If move left rb.velocity is equal to new vector 2 minus move speed comma rb.velocity.y. The way these touchable image elements work is that they only allow us to register when they get tapped and when they get released. So they register that controls when they are getting tapped and when they are getting released. That means we can't ask Unity whether the button is being pressed. The reason I told you not to paste that code just yet is that there is an earlier way to do this. We already have bunch of code to handle the player walking left and right at the moment. It includes things like animations, so we don't want to repeat ourselves. So that means we have added the controls. Instead, we are going to use a command called OR. This basically allows us to ask whether one of two things is happening. In this case, we are asking whether the player is pressing an arrow key or one of our booleans is true. In C hash, we write OR using the symbol of OR. So we were adding controls to our code. So we were writing code. So our code should look like this now. If move left or input.getKey key code dot left arrow, then parenthesis open, rb.velocity is equal to new vector 2 minus move speed comma rb velocity dot y. Now anim dot set bool walking comma true. If facing is equal to 1, transform dot local scale is equal to new vector 3 minus 1f 1f 1f. Facing is equal to 0, parenthesis close and then close. Else if move right or input dot get key code dot right arrow. rb dot velocity is equal to new vector 2 move speed dot rb dot velocity dot y. Anim dot set bool is equal to walking true if facing is equal to 0. Transform dot local scale is equal to new vector 3 1f 1f 1f. Facing is equal to 1, parenthesis close close. Else anim dot set bool walking comma false. Now when you press right and left, your character should still move, but were you to set one of the boolean to true, So you are setting boolean to 0 and 1, that is true and false. When you set one of the boolean to true, remember all variables equal 0 by default. When the first created, that is false, then the player would move automatically. So here we are dealing with boolean. Likewise, I want you to move the code that is handling the jump action of your player character into a new public method. A public method is a method, a snippet of instructions that can be executed from other classes, that is script. That means we can now force the player to jump by activating it from external script. So jump was a command. We still want to register the button press in our update method, but instead of including the jump, we are referencing the new public method that contains said code. So you will be creating the public method like so: public void jump if on ground rb.velocity is equal to new vector 2 rb.velocity.x jump power bracket close, and then from within the update method you will simply say this: if input.getKey code dot space in bracket jump. The whole thing should look like this: void update if move left or input.getKey, then key code dot left arrow rb.velocity is equal to new vector 2 minus move speed comma rb.velocity y anim.setBool is equal to walking true if facing is equal to 1 transform dot local scale. So this is updated code actually, is equal to new vector 3 minus 1f 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 facing is equal to 0, else if move right or input dot get key code dot right arrow rb dot velocity is equal to new vector 2 move speed comma rb dot velocity dot y anim set bool walking comma true if facing is equal to 0 transform dot local scale is equal to new vector 3 1f 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 facing is equal to 1, else anim dot set bool walking false if input dot get key then key code dot space jump. So this is for jumping. Public void jump if on ground rb dot velocity is equal to new vector 2 rb dot velocity dot x comma jump power. Okay, so now we have done that. It is time to make buttons responsive. Start by creating another new script, this time called touch. Dot touch is going to contain following code. Okay, so now we have done that. It is time to make buttons responsive. Start by creating another new script, this time called touch. Dot touch is going to contain the following code. So here we are creating a script called touch. So this is for touching that Android screen. So this is code for touch. Public class touch mono behavior public player void start player is equal to find object of type player public void dot press left arrow player dot move right is equal to false player dot move left is equal to true public void press right arrow player dot move right is equal to true player dot move left is equal to false public void release left arrow player dot move left is equal to false public void release right arrow public dot move right is equal to false public void jump player dot jump. This is basically a collection of public methods, each of which is going to interact with the player script class in one way or the other. Now head back to Unity and add this new touch script as a component to touch controller empty game object. So we have written the script, so we have to add the script now. Now head back to Unity and add this touch script as a component of touch controller empty game object we created earlier. Now we are going to add a component to left arrow, this time a new kind of called event trigger. So to add a component event, then event trigger. So here we are adding an event trigger. Now click add new event type, pointer down, click the little plus symbol that appears on the right, and then take the touch controller game object and drag it into the known object box. Then click the drop down menu on the right and select touch, then press right arrow. Basically, if you are telling Unity that you want the pointer down event, that is the action of pressing the button. To trigger the public method, press left arrow, that is within the touch script. Click add new event type and then choose pointer up. This registers the action of finger being lifted from the arrow. Now select touch, release left arrow to go in here. As you have probably guessed, you need to do the same thing for the right arrow by using the respective right arrow method. For jump button, you are going to do something very slightly different by ignoring the pointer up type of event and choosing jump method for the pointer down. Creating your first APK. Now that you have an appropriate form of input, you can finally actually test all your hard work on an Android device. First, make sure you have saved your scene. So you have to save the project for make sure your hard work is saved again by pressing Ctrl S. So we have to press Ctrl S. Next, head over the file build settings and you will see a box at top of this window that says scenes in the build. This is basically showing you which of the scenes you have created you want to include in the final product. To add your level 1, so here we are building. Just drag it from your scenes folder in project window and drop it into scenes in your build area. For now, don't worry about texture compression. That is useful for creating 3D games and it will help you optimize your apps. For our purpose, right now it is not necessary. Our app is pretty small and not very resource intensive. So so we have to think about the texture compression also when we are doing complex stuff, and not all types of compression are supported by all Android platforms. I discuss texture compression more later in this book. Player settings. Next, click the player settings buttons beneath the platform scroll box and you will find that some of new objects open up for you to play with the inspector. So these are settings for player. This is where you can find many of the properties of APK you are about to build, the things like the icon and the package name and the orientation. So here we are changing a lot of stuff, that is the package name and orientation, etc., that is portrait landscape. Resolution and presentation. The first thing we are going to look at resolution and presentation. At the moment, the default orientation is probably set to auto rotation, and beneath that there are tick boxes showing which orientations are permitted. Right now the answer is probably all of them. If you want to make a puzzle game, there is a chance you will want to support a portrait orientation. Preparing your phone. Preparing your phone. One more thing to do before you can try running your game on phone is to prepare the phone. So we have to enable developer options in our Android phone also. So we are testing this app. So for that we have to do some settings in our phone. One more thing to do before you can try running your game on a phone is to prepare the phone in question. First, that means you need to allow USB debugging. So this is important option. You have to allow that USB debugging. Debugging lets you install apps over USB connection and then get feedback about how they are running. Usually this option can be found under a section within your phone setting called developer option. So this is found under developers option. Now pulling the trigger. Now all that is left to do is to build your apps and run it. Go ahead and plug the phone into your PC via USB port and then hit build and run. If everything goes according to plan, Unity will build APK and then install it on your phone. Technical difficulties. So we have to deal with some technical difficulties also while doing uh, programming or while uploading our app or creating our application. So these are few technical difficulties that we have faced, and uh, we should be aware of that and we should be solved. So we can google them or we can search them on internet. But here are some technical difficulties which we have faced. Unfortunately, when I did this, I ran into some technical difficulties that took a while to figure out. Fortunately for you, it's my job to deal with those things to make your life easier. After recently upgrading Android SDK tools, that are software development kit tools, it appears that compatibility has been broken and builds stopped working. So compatibility issues we are facing, and builds are stop working. That means if you have only recently installed Android SDK, things might not work as they should. The solution is to find an older version of Android SDK tools and replace the folder into SDK root directory. Rename the old one to tools triple X or something. Hopefully by time you read this, that little problem will be fixed. If not, you may have to do a little more googling. Unfortunately, this is the nature of development, and especially development on Android. But it does make everything all more rewarding when it finally does work. If everything has gone to plan, you should now having a working version of your app on your phone with touch control. So these were some technical difficulties that we were facing. Chapter 8, expanding the game world with checkpoint, level and save files. With that said, there are still at least a couple of elements we have not covered yet that are pretty much compulsory. If we want your game to feel complete, those are what this chapter covers. So we are discussing about checkpoints, levels and save files. First, if your levels are going to be more than couple of platforms long, you are going to need to introduce checkpoints so that your player do not get frustrated by being constantly sent back to start. That means if the player is dying or it loses, so it will be sent back to that initial position, and that is start of our level, and he will get frustrated. So checkpoint is also important. So first you, if your levels are going to be more than couple of platforms, that means your levels are going to be longer, you are going to need to introduce checkpoints so that your players do not get frustrated by being constantly sent back to start. So your player should not get frustrated. Second, you will probably also want to create more than one level and find a way to transition between them. And if you have more than one level, you are going to need some kind of select system, that is menu, and a way to save players progress. Adding checkpoints. Before you start adding checkpoints, it makes sense to make your level a little longer. This is the fun bit. So copy and paste some of the ground sprites around and in more spikes and water pools and let your imagination work. Run wild. So basically you can add checkpoint anywhere, in water, in ground, etc. Consider this level design a placeholder that will just give you something to run through as you play. Do make sure that there are some elements along the way that can kill the player, though. That is kind of required for checkpoints to make any sense. Now we are going to create our first checkpoint. This will simply be an empty game object that we are going to drop into the game at various locations. So we are dropping that checkpoint into various locations in our level. And guess what? We are going to call the first one checkpoint. So we are calling that first checkpoint as checkpoint. Later in the game, we may try combining multiple hazards in order to create sequences of challenges and thereby increase the difficulty slightly. First, give it a circle collider and tick the is trigger box in the inspector. This means we can tell when a user walks over the checkpoint, but they will not be able any wiser. Make this object quite large because it is important that player does not accidentally skip the checkpoint. So we have to make checkpoint larger so it may not accidentally skip this checkpoint. Scripting a more fitting death. If we want to move our player, it makes sense to do so by manipulating the variable in player script. We start creating two more public floats, start x and start y. So here we are talking about death of that character. The start of game is effectively our first checkpoint. So uh, the start of game is our first checkpoint means the player starts to play from start. That is why it is our first checkpoint. So the first thing we should do on spawning our player at start of game is to find out where they are in the world so that we can send them back to this exact point each time they die. So checkpoint purpose of checkpoint is that spawning means recreating or giving that player a new life, that is spawning. What we will do instead is check the position of the player when the object is first created and make a respawn position. To do this, you simply need to add the following bit of code to start method. Start x is equal to transform dot position dot x. Start y is equal to transform dot position dot y. The preceding code gets the position of the game object when it's first created and stores x and y coordinates separately. So basically these are two codes for those checkpoints. Now find your death method. This will either be in your hazard script or your player script. If the death method is in the player script, you can write this simply as follows. So death method, if we want to add in player script, then transform dot position is equal to new vector 2 start x comma start y. Otherwise, if it is still in the hazard script, it will look like so: player dot transform dot position is equal to new vector 2 player dot start x comma player dot start y. So this is hazard script. Scripting the checkpoint. You may already have figured out what is coming next. All we need to do with our checkpoint is change value of the start x and start y when they enter collider. Public class checkpoint mono behavior. Private player void start player is equal to find object of type player void update void on trigger enter 2D collider 2D other. If other dot tag is equal to player dot start x is equal to transform dot position dot x player dot start y is equal to transform dot position dot y. And do not forget, you also need to attach this script to checkpoint in question. Now make a few checkpoints in smart places and have a little play to see what works best. Organize them in your hierarchy in logical fashion too, perhaps by giving them a parent object called checkpoints. Of course, you could provide some kind of visible indicator to denote your checkpoints, such as the past found in the Sonic the Hedgehog games. So we can intelligently add checkpoints. Taking it to the next level, we have come a long way, but our game still only has one level. So here we are discussing about adding levels in game. It is time to introduce some form of real progression. To do that, we are simply going to make another game object that will represent the end of level and make this a trigger, creating a new level. Before we can add the script, we first need to create another level. That way any changes you make will be reflected globally across all the levels you make. Do the same thing for your canvas and its children. Once you have done that, try using this easy little trick to make a new level. Simply click file, then save scene, and as call it level 2. Make sure it is going into the same scenes folder as level 1. Escaping the level. Now that our game has more than one level, we are ready to make it possible to transition between them. So transition means going from one level to another level. Head back to level 1 and add the sprite to your first level as you normally would. Make it game object with a polygon collider. Tick is trigger. Create a new script called end level and add it to the component of the rocket ship. End level will look like this: using system.collections, using system.collections.generic, using Unity engine, using Unity engine.scene management, public class end level mono behavior, public string next level, void start, void update, void on trigger enter 2D, collider 2D other, if other dot tag is equal to player, scene manager dot load scene next level. The scene in question meanwhile is a public string which will name in the inspector as level 2. Building a level select screen. In most mobile games and PC and console games, for that matter, players can jump straight into a given level as long as they have previously completed the one before it. So in most PC games, if we want to go into previous level which we have already completed, we can do that. So in most mobile games and PC and console games for that matter, players can jump straight into a given level as long as they have previously completed the one before it. This lets them replay their favorite moments, go back to find hidden secrets, and beat the top scorers. To allow this, we need to provide some way for our players to view levels and select them. In other words, we need to build a level select indicator or selector should have transparent center. Writing a control script. Now we are going to create a new control script that will work much like player script. For the most part, we will be controlling the selector just as we would have controlled the player. This is our player character for the time being. So here we are implementing control script. Writing a control script. Now we are going to create a new control script that will work much like player script. For the most part, we will be controlling the selector just as we would have controlled the player. This is our player character for the time being. Create a script and call it selector, then use the following code: public class selector mono behavior, public bool move left, public bool move right, void start, void update. If transform dot position dot x is more than -5 ampersand move left, or input dot get key down key code dot left arrow. Transform dot position is equal to new vector 2 transform dot position dot x -6 comma transform dot position dot y. Move left is equal to false, else if transform dot position dot x is less than 1 ampersand move right, or input dot get key down key code dot right arrow. Transform dot position is equal to new vector 2 transform dot position dot x plus 6 comma transform dot position dot y. Move right is equal to false. If input dot get key key code dot space select public void select, my label images are spaced 6 units apart, so that is how much the selector will move with each step. As you can see, this is very similar to our usual player script, although obviously without the death method or animations. There are also one or two other differences that you also need to be aware of. We have created a select method, but for now it's empty. Instead, all that is happening is that the selector is moving 6 units to the left or right when the user taps the arrow key. You will need to update this each time you add a new level, or potentially use something like number of levels *6 to calculate how far the selector can move to the right. If you drag the main camera object to make it a child of the selector in the hierarchy, then the screen will scroll as our selector moves. Right now, if you test this, it should work as long as you are using the cursor keys to on your computer. Public class level select touch mono behavior, private dot selector void start. Selector is equal to find object of type selector, public void press left arrow. Selector dot move right is equal to false, selector dot move left is equal to true. Public void press right arrow. Selector dot move right is equal to true, selector dot move left is equal to false. Public void release left arrow. Selector dot move left is equal to false, public void release right arrow. selector.moveRight is equal to false. Public void select selector dot select. Add this script to touch controller game object in your hierarchy, not to prefab. Remember, we only want this change to affect this instance of touch controls and not the ones used in level 1 and 2. Ready to launch. Give this a try and you should find you can now move the selector around either the cursor or the screen controls. It looks pretty good, although it can probably benefit from a nicer backdrop of some sort. What it really needs is the ability to actually select the level. A good way to do this would be given our level images proper names, which will be same as our scene names, so level 1 and level 2, and make the selector itself a trigger with box collider. We also are going to add rigid bodies, which are useful for our collisions and detections. So that means we are labeling our different objects, and we are adding rigid bodies means uh, if our character touches them, it will collide with them. We obviously do not want our levels to fall off the bottom of the screen, though, uh, because of gravity. So click the little drop down menu and next to body type in order to choose kinematic. Saving our progress. Level select is not much use until we can save our player's progress. We want there to be a sense of accomplishment and progression as they play through the levels, which means that the option to play further should open up as each level is completed. So, option to open up means we go to next level. So we need a way to save our progress. So we are saving our progress. That means we are going into next level and first level is saved now. And Unity actually gives us a number of options, from using player preferences to serialization or creating text files. Technically, what we should be using is serialization. It lets you save a lot more information more quickly. For now, we are going to use player prefs because it is quick and dirty and much easier to get head around. So here we are using prefs. Player pref is supposed to be used for saving preferences like image quality, or whether you want the sound on settings. That means sound on setting means sounds in game. In other words, but for honest, a lot of indie developers use this method exclusively. If all you need to do is store some top scores and level images, it will do just fine. It is incredibly simple to save the level as soon as we load it. Just update the end level script attached to the rocket it in level 1 to look like this. Public class end level mono behavior, public string next level, public int level value, void start, void update, void on trigger enter 2d, 2d collider 2d other. If other dot tag is equal to player, save level value, scene manager dot load scene next level, public void save level int level, player prefs dot get int furthest level comma level. That one line, player prefs dot set dot int farthest level comma level, is all it takes. This creates a new integer with the key farthest level and puts it in the player prefs. We just need to add the public variable level value in the inspector, and now touching the rocket will load up the next scene and update the saved variable. To make use of this, we need to make our level select screen a little smarter so that it will be able to show us when a level is not ready to be loaded. Create two of these and place the first one so that its size behind level 2 further back in order. If you get this right, it will not be visible. The second goes along the right when level 3 be later. So here we are saving the levels. We are now going to create another script called level loader and attach that level 2 image. Public class level loader mono behavior, public int this level, private selector void start selector is equal to find object of type selector, void update if selector dot farthest level this level. This dot tag is equal to off. Get component renderer dot enabled is equal to false, else this tag is equal to on. Get component renderer dot enabled is equal to true. So these images are now our level loaders. When the level select scene is created, they will all appear as they should, and they will check to see if the player has gotten far enough yet. If the player has not, they will disappear. Get component rendered dot enabled is equal to false and set the tag to off. Attach this to game object and then enter the public integer this level and inspector, which should of course be 2. As you can see the code, we need to check the level is going to be in the selector script because we only want to do this once, which has a public property load level. To get this value, all we have to do is to add just one line of code to start method in that script. Player pref dot get int, that is farthest level. Of course, we also need to define the public integer up top. The level loader images will then disappear if the player has not gotten far enough to play them yet when the player selects the question mark. They are still really selecting an invisible level 2, but because the tag is set to off, it won't load. A few final comments, give it a try and you should find that first you can only play level 1 only after you reach level 2 via the rocket, and then load this screen up again. You will be able to choose either progresses. So that means here our progress is saved that with rocket we are going into level 2, and after going to level 2 we can play both levels, but initially we can only play level 1. So we are going according to our plan. Chapter 9, adding more game elements, spring, moving platforms, AI and more. After all, a typical game will involve plenty of difficult obstacles, hazards and power-ups. So a typical game will involve obstacles, then hazards, that means different elements, each of which will normally create unique gameplay challenges and fun encounters. So this involves unique gameplay elements. So and fun encounters, that means it increases the involvement of the player in that game. Sonic has springs, rings, posts, badniks, spike pits, jazz emeralds, and loop de loops. So in this Sonic game, we have these kind of elements. Now Mario has mushrooms, bullet bills, ghosts, question mark boxes, and Yoshis. Mario has this kind of stuff. Now Super Meat Boy has portals, giant stars, missiles, and piles of used needles. So these are examples of different games. It is time for you to get creative and to start introducing more elements into your own game. And the best part, creating these challenges is almost as much fun as getting to play through them later on. So that means these are interesting characters in game. Now springs. The first game object we are going to create is the spring or bounce pad. Arguably popularized by Sonic the Hedgehog, the spring is now a common trope in the platformers, used as means of propelling the player up a level. So spring is one of the game objects. Take a look around the Unity ID and you may find something that looks like it will do the job. You can add a bouncing property to the physics material 2D. Unfortunately, that is not what we are looking for, because this will make the ground act a lot more like an actual bouncy surface. So bouncy is a script. Next you are going to create a spring script and add the following code. Now this is script for bounciness. So this is code: public class spring mono behavior, private player. Use this for initialization. Now void start, player is equal to find object of type player. Update is called once per frame. Now void update, void on collision, enter 2D, collision 2D other. If other dot game object dot tag is equal to player dot super jump. As you may have already guessed, you are going to add the super jump method to your player script. Public void super jump rb.velocity is equal to new vector 2 rb.velocity.x jump power into 2. Of course, remember to add new spring script to your game object and make it a prefab, the usual stuff. Now when you touch the spring, Kevin is going to be launched up into air at twice the height he can normally jump. Moving platforms. A common trope in any platform game is moving platform. You have platforms that move left and right and carry you over chasm, and you have platforms that move up and down and act like elevators. Essentially need to modify this script so that we can stick to top of surface and travel with it. How might we do this? So basically there are two kind of platforms which move up and down like elevator, and left and right. The answer is that we need to make Kevin a child of the game object he is standing on. We are not only changing the script so that our character becomes a child of the platform when they come into contact with it, we are also adding another dimension of movement so that it can also move upward and downward. So here we are adding platforms. I also recommend that you create a new physics material 2D for the platform and set the friction to something high. This is to prevent Kevin from sliding too much on a platform, which looks a little odd in conjunction with the movement. It is also a good idea to use an edge collider and add a platform effector tick used by effector and use one way, and this will prevent our player from getting crushed by the platform or sticking to the side and moving as a child of the platform. That means we are creating friction high or low with regarding to that platform. These platforms actually they are game objects which moves right left up and down like elevator etc, and we can add different scripts like rigid body 2D to it. Collapsing platforms, these are the platforms that crumble under foot when you land on them. So these are basically game objects with different scripts. That means these are colliding scripts. These platforms have gravity. These are the platforms that crumble underfoot when you land on them, and thereby encourage you to run and jump quickly in order to avoid falling to your doom. That means in Mario game we have noticed that there are some tiles which fall when you jump on them. With this kind of thing, it is important that you communicate to the player the nature of the challenge that they are about to face. It is not fair to sucker punch your player by having a platform drop put underneath them without warning, and for that reason it is normally advisable to have a visual indicator that ground is not quite stable. So basically on these collapsing platforms we color them differently. So we add different color on them to visually appeal that they are not quite stable. We want platform tile to begin to crumble once we land on it. So we are going to create a new script called crumble. This script will simply start a timer as soon as the player touches the object, and then cause the object to fall and disappear once the timer has completed. So basically this is a new script called crumble which helps in collapsing that platform. This is script for crumble. Now public class crumble mono behavior, private player private rigid body 2D RB, public int time to collapse, private int time to left, public int time to restore, private int restore time, private float start y, private float start x. Use this for initialization. Void start RB is equal to get component rigid body 2D, player is equal to find object of type player, start x is equal to transition dot position dot x, start y is equal to transform dot position dot y, time left is equal to -70. Update is called once per frame void update. If time left is more than 70 -70, time left is equal to time left -1. If time left is equal to 0, rb dot constraints rigid body constraint 2d dot known. If time left is equal to -62, get component renderer dot enabled is equal to false. Restore time is equal to time to restore. If restore time is more than 0, restore time is equal to restore time -1. If restore time is equal to 2, transform dot position is equal to new vector 3 start x comma start y. Transform dot rotation is equal to quaternion dot identity. Get component rigid body 2d dot velocity is equal to vector 3 dot 0. rb dot constraints is equal to rigid body constraint 2d dot freeze all. Get component renderer dot enabled is equal to true. Void on collision enter 2d collision 2d other. If other dot game object dot tag is equal to player, time left is equal to time to collapse. When the player touches the collider, that begins the countdown, which will be a value chosen in the inspector. The countdown passes 0, the constraints are removed from the rigid body, allowing it to fall and to rotate through the air. The timer carries on counting down past 0 to -70 so that we have time to see the platform fall and disappear. This is also set in the inspector, and when this counts down to 0, the object is returned to its original position with the constraints newly frozen, rotation set to 0, and rendering back. Better AI. Another thing you may want to add to your game at this point is better enemy AI. So AI is basically artificial intelligence, and here we are adding it to enemy. That means that enemy will move by itself, it will perform actions by itself. So another thing you may want to add to your game is better enemy AI, so which will make game more interesting. Right now our enemies just move left and right and are literally no more intelligent than our moving platforms. So here we know that our enemies are not intelligent, they move left and right as machines, so they are no intelligent. So that is why we want to add this. Something more challenging for the player would be an enemy that would actually seek the player out and chase them down. So the enemy which is after the player, or it will chase the player, or so that kind of enemy will be more interesting, and that is why we are applying AI. I think something ground based would be more interesting here. So I have created another enemy. This time I am going with a mechanical rat. So this is about basically a ground enemy called mechanical rat. We can create any kind of enemy. This little guy is going to use a new script which is called ground enemy. So ground enemy is a script which will be used for this mechanical rat. This simple script looks like slow. So here this is script for ground enemy called mechanical rat. Public class ground ground enemy, mono behavior, private player, private int facing, public float enemy speed, void start, player is equal to find object of type player, void update. If game object is equal to transform dot position dot x is greater than player dot transform dot position x, game object dot transform dot position is equal to new vector 2, game object dot transform dot position dot x is equal to minus enemy speed, comma game object dot transform dot position dot y. If facing is equal to 0, if facing is equal to 0, facing is equal to 1, transform dot local scale is equal to new vector 3, point 2f, 1f. If game object dot transform dot position dot x is less than player dot transform dot position dot x, game object dot transform dot position is equal to new vector 2, game object dot transform dot position dot x plus enemy speed, comma game object dot transform dot position dot y. If facing is equal to 1, facing is equal to 0, transform dot local scale is equal to new vector 3 minus 2f dot 2f 1f. Fun fact, the first game I ever made was based around this script, except in the basic for the ZX Spectrum. This was the point at which I got programming. I made a dot that could move around the screen and would be chased by second dot. The player's objective was to trick this enemy into landing or some mine. So this is basically about that AI, introduction of AI. Anyway, this script is a little too simple at the moment, as it is the enemy will start chasing the player as soon as the player game begins and probably end up stranded in a pit somewhere. Not only that, but he is very easily fooled and will stymied by pretty much any obstacle. So basically we introduced AI. The proximity will be a public integer that we can set in the inspector, a useful tip to make sure that you play around with different ranges and different speeds. Notice how tweaking these numbers even just slightly alters the pace and the tension of your game considerably. This is similar to being a film director. So like a film director, we are changing our scripts of our game. While we are at it, why don't we get a little more creative and give our enemy the ability to transverse the environment a little more. So that means we are adding a more and more complexity in our game. For example, it would be great blocks to try and reach the player if it could get itself out of pits. To do this, we will be using a new feature, raycast. Using raycast are little like the reverse sensor in your car. They send out a beam that checks for collision and then true if there is a hit. So this is basically a sonar system, that means sound navigation ranging system, which is used in ships or our reverse parking sensor in our car. So raycast are little like the reverse sensor in your car. They send out a beam that checks for collision and then true if there is a hit. So there is a hit means they tell that uh, if it is true or not. So if there is a hit, then they will send true. What we want to do is to give our enemy the ability to see if something is blocking its path and then jump over it. So we are blocking our we have to see that if something is blocking its path and then jump over it. Handle this the exact same way you did for the player. Create an empty game object with small radius and then get it check for some ground to set a boolean. You can copy and paste the code directly and it should then look something like this in one place. Public class ground enemy mono behavior, private player, private int facing, public float enemy speed, private bull chase is on, public int attack range, public transform ground check, public float ground check radius, public layer mask what is ground, private bull on ground. Void start player is equal to find object of type player, void fixed update on ground physics 2d dot overlap circle ground check dot position ground check radius what is ground. The raycast is an invisible line and we are going to use more transforms and empty game objects in order to define its position. So a raycast is an invisible line and we are going to use more transforms. To check that this is working, we are going to use debug function to draw a straight line between 2 points. This is handy features of Unity that lets you draw directly onto the screen in a way that is only visible in the scene view. So create two new empty game objects that are children of rat. The first one should be dead center, which we will call side start. The second will be 2 units in front of the rat and will be called side end. So we are creating here two game objects. First one is side start and second is side end. Once again we will use the inspector to drop the two empty objects we just created into there. If you have done this right, you should be able to add this line debug.drawLine enemy side start dot position dot enemy side end dot position color dot red. Our raycast is going to precisely where the line is currently, but it can be useful to keep the line anyway, seeing as the raycast are completely invisible. We are going to use physics2d.linecast. For this job, there are other kind of raycasts such as circle cast, but for a 2D game with simple rules, a line is the most efficient option. We need to give this function a start point and end point as we did with our line. And then we are also going to provide a layer mask. We do not want enemy to jump over the player, so the layer it is looking for is ground. This will go inside the update and will only operate is chase is on. Boolean is true, that is if the player has been sighted. If physics 2D dot line cast enemy side start dot position enemy side end dot position, what is ground? Jump. As you can see, I have also created a jump method just as we did for the player. This should be familiar. Private void jump. If on ground, rb dot velocity is equal to new vector 2 rb dot velocity dot x jump height. This is actually all it takes for our enemy to now be aid to leap over obstacles. Arming the player. Creating a bullet that the player can fire is relatively easy, though we will need to do a little juggling to make sure we are referencing the right instance of our bullet object. Allow me to explain. First, we need to create a new game object called bullet. This is our bullet, which will have public variables for its direction and speed. It will also have a collider. So here we are creating a bullet for the player. The script should look like this: public class bullet mono behavior, public float speed, public int direction, private int time left, public game object blood. If time left is less than 1, destroy game object. If direction is equal to 0, game object dot transform dot position is equal to new vector 2, game object dot transform dot position dot x minus speed, game object dot transform dot position dot y. Else if direction is equal to 1, else if direction is equal to 1, game object dot transform dot position is equal to new vector 2, game object dot transform dot position dot x plus speed, game object dot transform dot position dot y. Void on collision enter 2D, collision 2D other. If other dot game object dot tag is equal to enemy, destroy other dot game object. Instantiate blood transform dot position transform dot rotation. Else if other dot game object dot tag is equal to player, physics 2D dot ignore collision. Other dot collider get component is less than collider 2D, else destroy game object. Notice that killing a rat will cause some bloody particle effects that occurs when player dies. Notice too that our on collision method checks the object tag so that rats gets destroyed with the blood, players gets ignored, and anything else destroys the bullet. The bullet also times out after a set duration and self-destructs to remove itself from memory, just like the particle effects did before, and then add the following bit of code: if input dot get key down, key code dot left control, where new bullet is equal to instantiate bullet dot transform dot position transform dot rotation, where bullet script is equal to new bullet dot get component bullet, bullet script dot direction is equal to facing. This is the new part. Here we want to not only instantiate a new object but also set some of the properties for that object as it is created. To do that, we need to use get component in order to get the reference to the script from this instance. Of course, later on you will want to go into your canvas and add a fire button. I am leaving this out as I think that the bullet makes our player a bit overpowered. This section here simply for our own reference and so that you can add bullets and guns to your game if you want to. Likewise, you are also going to need to add a gun of some sort to your player sprites and possibly a new animation. So here we have successfully added a gun to our character.
Chapter 3. Finding your way around Unity. So Unity is now up and running, and there's nothing left standing in your way. Time to get going. Before you build anything, let's first get you acquainted with the different UI elements, controls, and options. You're going to be spending a lot of time here, so it's a good idea to familiarize yourself. What's all this then? Getting acquainted with the IDE. When you get your first look at Unity, figure 3:1, it can all appear rather confusing with lots of different windows, menus, and options. Fortunately, it's all a lot simpler than it looks once you get going. We'll go over what each of these different views is for over the course of this chapter, and at the same time we'll be able to test our first very simple application. Figure 3:1. Welcome to Unity. You'll be spending a lot of time here first. The views. 39 Copyright Adam Sinicki 2017a. Scene. Right in the center of Unity is a view called Scene. This is where a lot of your work is going to get done and is essentially the window where you'll move your various game objects and arrange everything. This shows you a view of the level menu screen that you're working on at any given time and lets you select and reposition elements around the screen. You can zoom in and out, and if you were in 3D mode you'd also be able to move the camera around 360 degrees. Asset Store. At the top of the scene window, figure 3:2, are two tabs that allow you to change between two different functions. Hit the Asset Store tab, and as you might expect, the scene view will be changed for the Asset Store view. The Asset Store is where you browse for various assets, scripts, game objects, sprites, effects, and more, to include in your own application. These assets are developed by other Unity developers, as well as by Unity Technologies. Some are free and others cost money. Some are very simple additions to existing projects, whereas others are practically entire ready-made games for you to edit as you like. Figure 3:2. Scene, Game, and Asset Store tabs. In short, the Asset Store makes your life considerably easier by ensuring that you won't need to create every single script and sprite by hand. That said, this isn't something you're going to be needing for a while, so for now keep the tab on Scene and don't worry about it. 40. Game. There may be a third tab on this window, as shown in the preceding figure, called Game. This view is where you'll see the actual game as it will appear when it's live. And when you play the game, this is where it will be located, unless you choose to maximize the game as you play it. If game isn't located in the same place, it will be around there somewhere. You have freedom to change the positions of the windows, and sometimes after an update, the default setup can get moved around. Most people should find that everything is in the same place and they can follow along with these instructions. If not, you should be able to locate each element pretty quickly. You can't drag and drop elements into the game view, as you can in the scene view, and you can't select them or move them around either. That said, for the most part game view will mirror what you're seeing in the scene view with a few differences. For one, the perspective will be fixed to the in-game camera, meaning you'll see what your players will see when they launch the game. Likewise, when there are multiple items sharing the same X and Y coordinates, the item on top will be the one closest to the camera along the Z-axis, rather than the one selected. If this all sounds a little confusing, don't worry about it. It will make sense once you see how it all works, and that applies to all the windows. Services. Usually located to the right of the scene view is the Services tab, which shares a window with the inspector. This includes such things as ads for monetization, analytics for learning about how your players are enjoying your games, multiplayer, and so forth. Note that some of these features will be missing or limited if you have the free version. For now, you can completely ignore this window. These services will mainly come into effect for more ambitious projects and only once those apps are live in the Play Store. Inspector. Next comes the tab that often shares its window with services, the Inspector figure 3:3. The Inspector is what you will use to see and edit details of game objects. So when you select a game object like a sprite in the scene view, you'll then be able to use the inspector in order to view things like the name of the object, the dimensions, any scripts that might be attached, and so on. 41. Figure 3 to 3. Inspector and services. You'll be using the inspector a lot, so keep this where you can see it. Right now, though, it will be completely blank. Project. Normally located along the bottom of the screen is a window for the project and console tabs, and sometimes game will be here too. The project tab should be open by default and is where you can see all the individual files associated with your project. Along the left portion of the window is the directory where you can select a folder, and on the right are the contents of that folder. Right now, your project only has one folder called Assets. And in that folder is nothing. This will be a useful window as you work because it will allow you to find sprites that you've created with other software and rename or delete files that you need for your game. Console. Next to the Project tab is the Console tab, figure 3 to 4. This is where you can get information regarding the status of Unity in your app. You'll be able to see debug information, crash reports, and errors, and this can help you identify issues in your code or work out just why your game won't run or compile. This will come in handy, but we won't need to worry about it for a little while, so keep Project visible in front of it for now. 42. Figure 3 to 4. The hierarchy and console. Hierarchy. Finally, one of the most important elements in the UI is the hierarchy, shown in figure 3 to 4, which is almost always found on the left of the scene view. Hierarchy shows a list of all the game objects in your scene at any given time, and when you select one of them the scene view will center on it. It will also be opened in the inspector. This lets you quickly find specific game objects to make edits, and it's also the only way you can select and visible objects like checkpoints. The hierarchy can also be very handy when you want to select multiple objects, maybe all of your collectibles, for example, and has a useful search utility for quickly retrieving specific items. Keeping a tidy hierarchy is good practice and will help you to work a lot more quickly and efficiently going forward. 43. Housekeeping. I recommend that you leave the windows in their default configuration in most cases. They have been arranged like that for a reason, it works, and this will make it easier for you to follow along with the instructions in this book. The console or others might not be in precisely the same place, but we'll mainly be using the scene, game, project, and inspector windows for now. Don't worry about the rest. But if you find that the UI feels cramped or you just don't like the way it's arranged at any point, you can hover the mouse pointer over any of the dividing lines to change the relative sizes. You can also drag tabs from one window to another, close them entirely, or bring them back using the options in the window menu. You may have already noticed that there are additional windows that you can open, found in the window menu, including the likes of Audio Mixer, Animator, and Sprite Packer. Some of these we'll be using later, but for now you don't need to worry about them. You should be able to do mostly everything with the hierarchy, scene, project, game, asset store, console, and inspector windows. Getting your toes wet with objects and scenes. That's enough theory, time to get practical. To really understand how these windows work and what you need to do to get started, the best thing to do is to start building something. Once you do that, you will see firsthand how everything works together and how you'll manage your workflow once you get developing. Adding sprites. To get started then, let's begin by adding our first game object. That is going to be a simple 2D square. Unlike working with 3D objects, there are no simple shapes for you to insert in 2D. That means that any 2D objects you introduce must be created first as sprites. Creating a square is simple enough, though. We can literally start a new MS Paint file, resize it to 50 by 50 pixels, and then just fill the space with a single block color. Save that as a PNG file and drag it from wherever you saved it into your project folder. Call it square for simplicity. You can see my square in figure 3 to 5.
You too.